cosmic grand design. Universal world so fast. Moments here they never last. Floating through the starry past. Journey far, we're going fast. Nebulous and colors bright. Painting dreams in every night. Astronauts in endless flight. Chasing stars and chasing light. Black holes hide where we can't see. Secrets they will always be. Yet we dream relentlessly in the space where souls roam free. Universal wide so fast. Moments here they never last. Floating through the starry past. Journey far, we're going fast.
Hey everybody, welcome to SkyTour livestream. So nice to see you all here already. It's so cool. As you can imagine, SkyTour livestream won't be the same without, guess who? Daryl Mason. Hello Daryl, how are you?
I'm not sure now. That sounded like a threat. Hello everybody.
Yeah. No, hey, I just want to mention to everybody that, we're actually looking to do some expansion to our observatory. So if you guys see your way to donate, please go to skytourlive.org and give it a shot. We'd love to have you. We would really enjoy being able to provide this to you. Our new observatory is going to cost us obviously more money than we've been paying. So if we can get a couple $100 more a month for us, that'd be great. So it's entirely up to you guys. If you can swing it, we'd love to have it. One-time donations are great too. Go to skytourlive.org and just click the donate button, and you can just give any amount if you want. It's not, obviously, we're not telling you you've got to, of course, but it does have benefits. And if you join the Patreon, we're starting up getting you some swag, mugs and so forth for certain levels of donation, kind of like National Public Television does. Kind of, they beg you for money, right? And then for like $300 you get a silly mug. I never sat right with me, but we can do something a little better than that. But it's up to you. I'd love to have you. And because check this out right here. This is the Pelican Nebula, the head of the Pelican Nebula. Look at the detail in here. And let me tell you, right now we're only at 50% the size of the sensor. Okay, here is 82%, 86, right? And then we come up to here and we're at 100%. So this is the size of our sensor. Look at all that detail in there. That is really something else. If I zoom out, I'll show you what it really looks like. Okay, this is what the Pelican looks like as a whole. This is our full field here, and we are excuse me, and we are doing some little pre-processing on it here, so you can see a little more. We can keep doing it to kind of pull in some of the fainter detail in the background there. But look at how gossamer and delicate that is. Isn't that beautiful? And I have to say, thanks to Daryl, we're gonna look at another object tonight that I forgot about, but had always known about, and so did Daryl. We just until he mentioned it tonight, I said, "Wow, I guess it's that time of year."
Yeah. Well, I've seen it come up recently, mentioned, and might have been an anniversary or something. I forget. It's one of them things I've never seen. I always meant to ask about. I know a little layman's knowledge about it. That's about it.
Yeah.
So if we can see it, so much the better.
Yeah. Now this
Hey.
thing we're talking about is 11,000 light years away, and at 11,000 light years, it's from here. If we measured it in the sky and calculated its distance, which we haven't done, other astronomers have done, we'd find that it's 5 light years in diameter. So that's gonna be kind of cool. That's not this. Okay, the Pelican is not that. We're gonna look at something else here in a minute.
I see the not the aardvark, the opossum looking over the pelican's shoulder.
Oh, right here.
Sure, don't you see that?
With his eyeball.
Yeah, that's one eye, and the other one's over to the left.
This one.
Yeah.
Here's an
and,
eye socket, an eye socket.
I used to think it was a raccoon. It looks more like not an armadillo, a possum. I should
Yeah,
know,
because
right?
he got an ear there, at top of his head, another ear. I guess we
grew
could.
up with possums.
Yeah, I had one outside my door the other night. I went outside and he was looking at me like, "Hey, how you doing?" And I was like, "Hey, how you doing?" I called him, forget Poss or something like that. I gave him a name. And Curtis Horn is here and says he sees Deadpool as well as other people. All right, guys, you tell me where you see Deadpool here.
Yeah, now that he mentions it.
Is it this? The possum is Deadpool?
Yes,
Okay.
sure.
Mm-hmm.
You must not have any imagination. Goodness.
No, it's,
Hey, I want to back up for a minute.
yeah, go ahead.
You were talking about making a contribution at skytourlive.org.
Yeah.
You're getting a little plug here, okay?
Okay. Well, thank you, Daryl.
When you go to do so, I mean, what are the terms of payment? Is it PayPal or credit card or what?
I believe that it's several different methodologies. If Marianne is watching, she'll be able to tell us right now, I'm sure.
Okay, yeah, I suppose if, well, we should talk about this offline. Anyway, I'm bundled of nerves and curiosity tonight. Carry on.
No problem. So, what we're gonna do here is, as you can tell, just look at the number of exposures here. I'm up to 96 exposures. I've been sitting here for a while with this. I want to welcome Michael Tarr to the chat. Michael Tarr is back. That's known as Calibos. Hey, Calibos, how are you?
Calabos.
Yeah, I'm glad he's back. I talked to him the other night, actually. It's very nice to talk to him finally.
And Tiffany's here, too.
Yes, she
I'd
is.
say hi, everybody, but I'm so far behind, I would never catch up. So, hello, everybody.
Well, that's okay. I do want to say, actually, that Tiffany was the first one here. Hi, Tiff. Great to see you. Maya Leone is with us again. Hey, Maya, I haven't seen you for a while. Tim F. is with us. Carl Becker, Rockstar, is with us. Stan from Two Rivers Observatory is really cool. And let's see. Okay, Water Rat is here. That's Matt. He used to work here with me in the special effects shop here. He's a cool guy. He did model work for the show Home Improvement. With Tim Allen. He's really talented guy. Okay, that's Matt. Donald Kunzer's with us, and of course I mentioned Calabos. It's actually really good to see him. And Curtis Horn, we talked about just a moment ago. He's here. Curtis is a really smart guy, and if you do have any questions about astrophysics, you can ask him. You can ask me. We both love this stuff, and Curtis is a tantamount genius level guy when it comes to this stuff. So this is really cool. And of course, SkyTour Live fan is with us. How you doing, man? I think that's Evan, if I recall. Yeah, go ahead.
I have something to say to SkyTour Live fan.
Okay.
SkyTour Live fan, if you've been thinking about old school telescopes lately, you think they're cool, go find old books like 60s, 70s, 80s vintage telescope construction books for amateur telescope makers,
yeah.
ATMs they're sometimes called, you will see some of the coolest telescopes and people who put their ideas into what they created.
Yeah.
There's a lot of really cool old books about that. I have them here at my library someplace.
Yeah.
Also look for the book Unusual Telescopes. That is an excellent book.
You know what I wanted to do, Daryl? I never could realize it because until recently I didn't have the technology to actually do it. And that was, I wanted to actually make an observing chair, which exists, and have a pair of binoculars or a set of binocular telescope set up that you sit behind. I mean, and people have done that. That's been done. What I haven't seen done, though, is have a go-to system where you actually say, I want to go see the Crab Nebula, and the whole chair goes and goes and shows it to you. I didn't, and they have image intensifier eyepieces that you can use. And we're not talking a cheap thing, but you'd actually see a view like at the Pelican. You might see it kind of like this, a little less so. It'd probably be more like. Maybe more like, let's see here. Let me pull it back a little bit. You'll see the brightest part of it. You might see it like that, with an intensifier.
Binocular telescopes were a thing.
Yeah, I know.
Years ago,
yeah.
And binocular telescope chairs were a thing. Sky and Telescope magazine
Sure.
used to feature them rather regularly at one time.
Yeah.
It could be as simple as a motorized dentist chair with a regular pair of binoculars on a bracket hanging over you, that you could
Sure.
bring to your eyes. Or it could be two complete telescopes slaved to each other and riding in a big Altaz platform. I've seen them motorized. I'm sure there have been go-to systems also.
Yeah, I haven't seen any, but I'd love to
Yeah.
see what those look like. Yeah,
That was a big thing.
it was. I remember.
80s, 90s, I guess.
Yeah, well, it's still popular at star parties and stuff.
Mm-hmm.
Yeah.
I have a matched pair of 8-inch f7 mirrors. They've never been coated. They're
Yeah.
still in the box. Made specifically for a binocular telescope. And it's one of them projects I never got around to.
Yeah.
I should sell them. I'm sure they're worth some money.
Yeah, probably as a pair.
Yeah. And I've made you show pictures of my binocular telescope.
Oh yeah, it was really nice. A blue set, a blue pair.
Won't bore you with it again. That was a few $1,000s right there.
I know it was. I mean, you had engineered a really nice, unique mount. It was easy to handle with gloves on. I mean, it was basically made for winter viewing too.
Oh well, the pictures were taken at Christmas 20 years ago.
Cool.
Anyway, yes, that's another one of those projects I'll never get to is a binocular chair. I have pages and pages in old notebooks going back decades of all my sketches for telescope design ideas, and believe me, there's more than one binocular chair in there.
There is. I want to welcome Richard Spencer. Hi, Richard. How you doing? Sean Hutspeth is with us. Hi, Sean. Matt, who's Water Rat. Matt, why do you give yourself such a water rat? Holy cow. Anyway, Water Rat asked a question. He asked about supermassive black holes because he heard about the story about the Sombrero Galaxy, measured 104, with a black hole at its center, a supermassive black hole. And he said it was compared to the Milky Way's black hole galaxy. And he asked, do all galaxies have a black hole at the center? We can't say with absolutes all galaxies, because some galaxies, like dwarf galaxies, may have had them ripped out of their centers. But yeah, most galaxies do have a supermassive black hole, an SMBH, a supermassive black hole, at their center. That's the current thinking. Also, the globular clusters we see maybe also have black holes, not supermassive like galaxies, but somewhat massive black holes at their center. holding them together too. It's kind of interesting, to consider that might be the case, right? Breaker 19 for Water Rat.
One of the points they made about the new web images of the sombrero,
Yeah.
which I thought happened years ago, but I guess not. It just happened in the last week. The supermassive black hole in the sombrero is comparable to the supermassive black hole in Messier 87. It is that big.
That's several solar systems.
It was like 8 billion solar masses or something, they said. It's much bigger than the black hole at the center of the Milky Way.
Yeah.
Yet, oddly enough, unlike M87, not a lot appears to be going on in the center of the galaxy. It's almost like two galaxies in collision, or a ring galaxy with an elliptical galaxy stuck in the middle of it. That's relatively faint.
That's actually a very interesting point. First of all, hi Kathy Messick, who's here. Nice to see you, Kathy. Kathy is a great supporter of SkyTour. And you're right, because when I looked at that sombrero galaxy image, I was struck by the fact that we take pictures. You see the big halo in the center, the nucleus. But remember, the Webb telescope is not taking pictures in the same light that we're imaging with.
Yeah.
It's taking pictures, and of course I'm talking to everybody, obviously, because Daryl knows this stuff cold. It's taking pictures in the infrared, and not just the infrared, but the far infrared. If for instance, if the infrared was, say, 1 inch to the right of our visible spectrum, then what the Webb sees in is like 10 feet to the right of our infrared spectrum. So it's that much of a difference.
It takes images in both mid and far infrared.
Yes, it does. But
with the NARI and the mid IR cameras.
That's right. And what happens is the reason that they did infrared for this telescope was because most of the information coming from distant galaxies has been red shifted. That is, shifted toward the red. Because Edwin Hubble noticed that galaxies that were farther away had what was called a redshift. Their light was shifted toward the red. So when we look at the spectral lines of, say, emission of hydrogen, we see a spectral line for hydrogen alpha, and it's in a certain spot in the spectrum. Okay? Certain exact location, measured either in angstroms or nanometers, whatever. Okay? However, if we see a hydrogen emission, say, coming from a distant galaxy, that would be shifted toward the red end of the spectrum for some reason, and that was due to everything from interstellar extinction, intergalactic extinction, all the way to extreme redshift caused by the Doppler effect with light, okay? And so the shift occurs just like in light, the shift is in color. In sound, the shift is in pitch. When a car goes by you really fast with its horn going, it goes, eew. You hear that pitch change. Well, that eew is longer wavelength, lower, okay? However, with light, that quote-unquote pitch change is in light color. So you'll see that the light is shifted to the red. And so that's what Hubble discovered. And the redshift became something that would hide galaxies from us, because some galaxies are so far away and moving so fast away from us. We also discovered that the farther away things are, the faster they're receding or moving away from us. And so when you looked at these distant objects, their light could be entirely not in just the infrared, but in the far infrared. So they had to build a telescope to see all the galaxies we could never hope to see. And that's what the James Webb is. And it has seen galaxies we never knew were there, because all of their light is shifted not just to the near infrared or the mid infrared, but the far infrared, way, way out, so far into the red. Yet, there may still be life in those galaxies, because from their perspective, we're the ones that are receding. It's really strange.
The other big thing the Webb does at infrared wavelengths is it can see through clouds. I've never seen a Webb image of the Pelican. I'd be curious to see it, but we could probably see deep into it, if not right through it.
Yeah, like
or through
right here.
Dark clouds either, surrounding it.
Right. These
That's
clouds.
all dust, and
Yeah.
that's what it was meant to do, was see through dust.
Yeah. Yeah. I mean, when you look at the pillars of creation, we've imaged it in visual light, like we do, and it's Messier 16, the Eagle Nebula. All right, and you see those pillars, and we've talked about those pillars. We see them in visible light. We don't see a whole lot of stars around them. The Hubble saw many more stars when it looked in the infrared, but then the James Webb looked at it with the farther infrared and was able to see 5 times the number of stars in that entire region that were hiding right in plain sight, but we could not see them because we couldn't see through the dark clouds that were between us and those stars. And the Hubble sees through. The James Webb sees through them, and the Hubble, to some extent, could see through them. Hubble does visual and it does infrared, but not really far infrared like James Webb can do. It's just awesome. So who knows how many stars are hiding in here that we just can't see? Okay.
Look at something.
Yeah, I'm just gonna save this. Okay, and save exactly as seen. I saved an annotation. Now, when I save this, that goes to our server, which is available at skytourlive.org. You can go there and scroll down, and it'll take you to this image. This image is probably already there. It's only taking about 30 seconds for these to go. And Donald Kunzer has a part 1 and part 2 question down below, Daryl. I wonder if you can grab that while I go check out something else.
Sure.
All right, we're gonna first of all, I'm gonna move to that supernova remnant we were just talking about called Cassiopeia A.
Okay. Donald, it's not a new idea that we are actually in a black hole. It's been posited before that black holes aren't really infinite density. I mean, the singularity is, but the bigger the black hole, the bigger the event horizon, and thus the spheroidal shape of it and what's inside it. Well, the density actually falls off with size. The bigger the black hole, the less dense the inside the event horizon is. And somebody did the math a long time ago, and basically, if all the mass we know of in the universe was inside a black hole, things just about balance out. That it, theoretically, we could be inside a black hole. And does that thus mean that every black hole has a new universe inside it? I'm not qualified to answer that, but maybe if it's a big enough black hole, I could, you're getting into white holes and
Oh yeah.
which direction time is going and all sorts of things. That a really big black hole, like maybe the one we're inside, means that we're a universe inside a black hole.
Yeah, one of the problems with that concept that I've always had is that when we talk about that, we have to consider that the gravity inside a black hole will be affecting us and affecting the light we see. So we have to think about that and consider what that means and how that will manifest itself in reality of looking inside a black hole. But I don't discount it, but I don't fully subscribe to it, but it's okay.
Well, it's all above my pay grade ultimately anyway, so I'm not going to worry about it.
Okay. All right, let's see here. It's one of these two. There it is. Okay, so we're going to go to this star.
I know this is up supposedly around the area of the star Elnath,
Okay.
which is one of the tips of the bull's horns. It connects the bull's head to Auriga the charioteer.
Yeah.
It's up between that, in the general area of Elnath and the Crab Nebula, supposedly not far away either.
Okay.
Maybe that'd be a bonus for tonight.
Maybe. It's a little low right now, but we'll get there. All right, so this is set here. So what I'm going to do now is I'm going to take us over to Cassiopeia A right there.
That wouldn't be in Cassiopeia, would it? Maybe I'm confusing something with something else I read. I'll have to go look that up.
Well, you mean Taurus? It's in the end of near Taurus.
Yeah, near the junction of Taurus.
Yeah.
Right.
Okay, so let's do this.
I'm a bad astronomer. Sorry.
No, you're not.
Go figure that out.
Okay, so let's see if we can. Okay, so there's no deep sky objects in the view. That's just the ones that it knows. I gotta talk to Robin Glover. I mean, I think I see the remnant right here, but we're gonna do a quick shot and see if we can see it here. Do 25 seconds.
Got the coordinates if you need them.
Yeah, no, I had them. I have them in the in Stellarium. I should see. What's that?
I am thinking of something else. I got my wires crossed there.
Okay.
Cassiopeia A is in Cassiopeia, of course.
Yeah.
So what was that other object?
Hey, Ron Wade, how you doing? Ron's up in Flag. That's Flagstaff. Science Bob. Hey, how you doing, Bob? Oh, look at it. There it is. Oh, yeah, very good. I was told yesterday that I might be testifying in Congress. All right, let me for UAP. It's pretty small. There's got to be more to it than that, right? I mean, there's the round thing, so that I don't think so. I think that's it. Let me color correct to bring out the colors a little better. Oh yeah.
And you are stacking.
Oh yeah. 2 so far. And let's get rid of some of this noise by dropping down this mid-level. There we go. So now you can start to see it. It's taking shape. It's this circular thing right here. And you can see this nice teal color coming through. I think we're catching the oxygen 3 that might be in there first. Yeah. Ron Wade says he can see the little observatory from his front porch. Wow, that's cool. Science Bob says it'd be a good idea for me to testify. Well, if I get the invitation, which I'm told could be forthcoming, then I will. But they gotta pay my flight. They gotta pay my hotel. I'm not gonna go down there, you know, when these senators and congressmen are, you know, they're...
You can't tell us why.
No, it's the UAP stuff. It was from when I was on that submarine that time. They had a unidentified object go whipping through the sonar at several hundred miles an hour. And that was something that I've talked about a number of times.
Yes.
Yeah. And Science Bob himself is also a witness to one. You know? Hey, Bob, we should testify together, actually, if they invite us. I'm going to mention you, too. He was on a boat called the USS Hampton, and he had a USO go zipping through at hundreds of miles an hour in his boat, too.
That name rings a bell.
Yeah, Bob McGuire. And he's Science Bob. Yep. SkyTour Live fan. I think your name, that's Evan, right, Evan? Is that you? He says, try to find Pluto as a space challenge. Well, it's not much of a challenge with the scope, but, I mean, picking it apart from all the many stars in the field
Right.
will be the challenge.
Pluto is not impressive. All you will see is one more tiny little dot amongst all the myriad of other tiny little dots of faraway stars.
Mm-hmm.
I mean, you see a little bit with Uranus and a little bit with Neptune, but Pluto is just You know, I could point to a star in this image and, hey, there's Pluto right there. That's about what you would see.
Yeah. I will say this, depending on the orientation between Charon and Pluto, Pluto does look a little bit more reddish. And when I looked at Pluto one time, it did look a little reddish, and that probably had to do with the way Charon and Pluto were orbiting each other, because they're tidally locked to each other. And so some of the reddish surface of Pluto was facing us and was illuminated. At other times you can't see any of that. You don't see the two either, but you just see the overall thing. Ron Wade, thank you for subscribing. Thank you as a new sub. Congratulations, welcome. He writes, Grandpa built us a 6-foot long, 5-foot high telescope when Halley's Comet came through, and we saw it pretty good from here. Wow. Were you down in Florida, down in that region, the southern United States? At the time? I'm not sure. Because you wouldn't have seen it from Flagstaff, I don't think. Actually, you might have. It was kind of low, though. But it might have got higher. I don't remember. Hi, Tricia. Ooh, you're live. Yeah, we're live. Absolutely. Okay, let's try and pull in some detail now here. Let's see if we can... I'm getting some reds now. Look at that, Daryl. See the reds? I'm getting some reds in there. There might be some other stuff going on in here. Might be other nebulae that it's...
I might be seeing a very faint kind of bluish object down around 5 o'clock, perhaps part of a ring.
Yeah, that's what I saw before, I think. Let me zoom in. I see this right here.
Yeah, I see it particularly on the right side.
Okay.
From about 11:30 down to about 5:30.
Yeah, 11:30 like this.
At least half the ring there.
I see this part very, very clearly. I also noticed that our focus is just a little soft by moving the telescope. And I say this many times. Often we've got to refocus the telescope, but I choose not to sometimes because it's close enough. But we really do have to refocus it. Now, if I kill this, it's okay because it's going to still be in the buffer. And I'm just going to quickly refocus, but it wasn't really focused. Sorry for that little nagging screen there, but if you guys can go to skytourlive.org and check it out, you know, we've got a lot to offer. We do equipment giveaways courtesy of Tiffany and Calabos, who are a pair of our super fans, super users. And we have also a lot of highly processed imagery that we provide to everybody as well, especially for the upper tiers in the Patreon. You can join our Patreon as well. All right, now I'm going to focus. Let's put this up here. Keep it out of the way. All right. Roy Batty's with us. Hey, Roy, how you doing? Thanks, Roy. I haven't seen that, but I'll check it out. He's telling us about a documentary called Aliens and Demons with Dr. Michael Heiser. Cosmo Edits, what's going on? You're a beginner, young astrophile here. Fantastic, man. I was 9 when I decided to become an astronomer, dude. I was 9 years old, and I never wavered. I ended up becoming an astronomer. I went a little into the ocean. I was thinking to be an oceanographer first, but I really felt that looking up was the answer, because looking down into the ocean, you learn everything about the ocean, learn a lot, but it was the universe that intrigued me for a lot of reasons. So that's where I went. But you're welcome here. Thank you. Make sure you subscribe and like us and do all those really good things that help us out. Excellent, dude. Cosmo Edit says, yeah, me too. Yeah.
You kind of managed to half answer Stan Two Rivers Observatory's question up above.
We did. I'm sorry. Could you read the question, and then if you want, you can take a stab at it too. I didn't see it. I apologize, Stan.
Being fairly new to this channel, can you give a brief talk on your and Daryl's background?
Oh, okay.
Brief.
Yeah. Daryl laughs because we talk about brief with me, and that's just like, it's hard to be brief. Thanks, Rock.
Thank you, Rockstar.
Rockstar is one of our long-time viewers, and admire Rockstar's tenacity to hang out with us. It's so cool. Yeah, okay. You heard mine basically, but I'll actually do it briefly. I was a 9-year-old kid, as I said, and I knew I'd be an astronomer back then. I just sensed it. I knew that's where I wanted to go, and so I did. I went to school for astronomy, and I got a degree in it. And it's like I decided I wanted to show people the stars, because if you've ever been to a star party, and Daryl's very familiar with this part of it too. If you've ever been to a star party, you look at the energy there and the passion. People want you to look through their telescopes. Come here, check it out. And it's just so much fun. And so that's what astronomy is about. It's about seeing something you've never seen before and exploring stuff you didn't know was there. It's the hidden world over your head. Just like the hidden world beneath the waves. Now Daryl will tell you about his background.
Also a lifelong interest in astronomy. I was doubtless 9 years old at one point.
Doubtless.
I started paying attention to the sky early, naked eye stuff. Always had the interest, though. I got my first telescope in 1981. I had a paycheck burning a hole in my pocket, and I've been doing it ever since. I had my first telescope when I lived up in Leadville, Colorado, highest city in the United States, 10,200 feet. I had a dead black sky. It's never really black, but you know what I mean. Right. And that's where I first cut my teeth on the sky. I've been doing it ever since. I used to do live presentations, star parties, public lectures and stuff a long time before the internet. It got to be too much like work, so I quit doing it. But I have more telescopes now, and I can shake a stick at it that I'll ever use again. Mm-hmm. I should probably start selling some of this stuff, like those two mirrors. That's it in a nutshell. I've seen some amazing things in my life. I mean, it's been 43 years now since the first telescope, and the number one thing I've ever seen has to be the solar eclipse in 2017. The second greatest thing I ever saw was the Leonids meteor storm back 20 years or so ago, 2001 I think, or 2000. Thousands of meteors an hour. It was just amazing to stand under it and watch it, awestruck. There have been many others. I can't think of at the moment.
Mm-hmm.
That's it in a nutshell. I got my degree at the School of Hard Knocks.
Well, that's
self-taught, in other words.
Well, Clyde Tombaugh, who discovered Pluto, was self-taught. He wasn't a professional astronomer in any way.
Yeah.
So you see, it doesn't matter. And there's a lot of citizen programs, citizen astronomers that are actually doing this kind of work now. And you can go to planethunters.org. You can get involved there. And sooner or later, you get noticed and things come your way. We're in a grant from Las Cumbres National Observatories to be able to have some hours of time on big telescopes around the world to do some research, and I've chosen Mu Cephei, which is a supergiant red star, and I've chosen Barnard star, a very fast-moving red dwarf star. And we're going to look for planets around both of those stars to see what might be there, to see the evolution of planetary systems in evolved star systems like Mu Cephei. Because it's an evolved star system. It's got no it's in its supergiant phase, so any planets would have been swallowed up if they're near it, but there might be planets outside that survived and might still be there and weren't boiled away. So we're going to look for that. And that's pretty cool. Cosmo Edit says, I never liked astronomy when I was younger. I was never interested in space, although I'm not sure how I found my way to like it. Maybe I'm just curious. I always liked to ask questions. Well, you know what? You're not going to have any problem asking questions here. There are no bad questions, of course. And I've probably said that line literally 150,000 times because it's true. There's no bad questions. And Bob says, Science Bob says, I built my first scope at age 10. I fell in love. My most active period was when I was at Brown. I used LAD Observatory. I know about that observatory. I was a member of the Skyscrapers. It was 4 years of astronomy heaven. Yeah. Yeah. Actually, there's a university here in Connecticut there's a university here in Connecticut that's actually rehabbed one of their telescopes, but it's not made for remote imaging yet, and they might want me to remotely remotify it, as I say, so that you can be run from anywhere. This telescope you see up above in the observatory, okay, Cosmo Edits are like this. Okay, this telescope here, we built that observatory, put that telescope in there, and it's 2,600 miles from me. It's out in the Arizona desert, and I'm in the state of Connecticut in the Northeast. So I'm running it long distance. So you see, Cosmo, you got all kinds of possibilities. You know, I built a telescope too, but it wasn't a regular telescope. It was actually a radio telescope. And that was cool. You know, really cool. I made the lengths of the wires on it. It was a wire telescope, wire frame, and I made the lengths of the wires such that we'd get the resonant frequencies, as it's called, from the sodium torus around Io. Io is giving off a bunch of sodium, and it has a whole. It's like Pigpen. It's dragging a ball of sodium in its upper exosphere, the area around the ball of Io, Jupiter's innermost moon, and it trails it around behind it. And it actually deposits that material on Europa and other, the Ganymede and Callisto to a lesser extent. But Europa gets the brunt of it, and it's really interesting to see how that works. You know? No, Bob, not the 21 megahertz line. That's the area, the hydrogen, we call it the zone of nothing, right? Because it's a little used frequency by the natural universe. So that's why the 21 megahertz band is favored for people looking for life on other planets. They actually send signals on the 21 megahertz neutral hydrogen frequency, because little space things, nothing uses that really in the universe that much. It's a kind of a barren band.
If you look at the image here, I just posted a link to a multispectral wavelength image of Cassiopeia A. It's by Hubble, Spitzer, and the Chandra X-ray observatories. If you see Mark's image here, you've got that big lump near center, and if you squint, you can maybe see a faint circle down below it, almost like the bright part is the diamond on a diamond ring.
Yeah.
And that actually corresponds well to what they saw with the Hubble, Spitzer infrared, and Chandra X-ray telescopes.
I'm going to pull it out a little more here, Daryl.
Yeah, you can see it now.
See, there it is. And it's in an area where there's other nebula, and so we're seeing some red diffuse hydrogen nebula in this region as well. Now, this is 11,000 light years away, and this distance across here is 5 light years. Okay, so if we were to zoom in, we might see either the neutron star. We won't see the black hole that's in the middle if it's a black hole. I don't know if Cas A went to a pulsar, a neutron star, which is also a pulsar but a special type. A pulsar is a special type of neutron star, or a black hole. It may be a black hole. I'm not sure what the progenitor ended up becoming. Do you know?
I'm looking right now.
Okay. We can see some nice filamentary structure on this. Wow. And the more we put in, the clearer it's going to get. We have 11 that we've taken right now. You can see right there. 11 right there. 11. Yeah, right there. Yeah.
I think there's some debate about what's at the putative center of the.
Yeah, I don't know. I have never heard.
I'm going to post the regular link in chat for the Wikipedia article on Cassiopeia A. If you care to take a look, you can learn more about it, and they actually have a bunch of really cool images of it in there in various wavelengths of light. Really neat pics.
Okay.
Well, I can see the ring now.
Yeah.
Even when you're zoomed in quite a bit.
It's pretty obvious.
11,000 light years away and 5 light years across. No wonder it's so small looking.
Yeah. I said hi to you, Stephen Jarrett. Good to see you. Thanks for coming. Make sure you like and subscribe if you can. We'd love it. We want to do some really impressive stuff with SkyTour Livestream. We want to actually have a Southern Hemisphere observatory at some point down in Australia. And we'd really like that. So if I end up traveling down there, it'll be in order to meet with folks to talk about the possibilities. I have some opportunities that may be presenting themselves. I'm not sure if it'll come through, but you never know.
You'll never get any sleep if you do.
No kidding. As it is, I got the solar observatory going here, out front here, and the solar observatory is going to be running all day long, and people can watch the sun during the day and look at the flares and so forth, because we have the telescope to do that. And then at night we'll do a sky tour, and then before January, February, it looks like we're going to be fully installed with telescope number 2 in Benson, Arizona, which is 202 miles southeast of this telescope. And that telescope is going to be a Celestron 11 with a filter wheel on it that will have narrowband filters in it, and it will also have the ability to do spectral analysis of stars. That's already built in. I already have that in there. So that's going to be pretty cool. Looking very, very forward to that.
Pity it won't be available either on the 7th of this month or I think the 14th next month. Jupiter's at opposition on the 7th, I believe, and December. And Mars will be at opposition in January. If you see Jupiter in the evening sky now, if you look over in the east toward Taurus,
you can't miss
the
it.
Hyades and the Pleiades, Jupiter is between the horns of Taurus the Bull, And if you keep looking farther over to the left, you'll see a little red object fairly bright, and that's Mars.
Mm-hmm.
I've got to figure out what the heck else I was looking at today that made me say that stupid thing about Auriga and Taurus.
Oh, I know what you were thinking of.
Yes?
The Spaghetti Nebula.
No.
Oh, okay. Because I want to try looking at the Spaghetti Nebula as well, but it's not available yet. It's still too low. That's another supernova remnant that's pretty cool. Yeah, Cosmo, the Southern Hemisphere telescope would be like down in Australia. And, you know, we're only seeing half of the sky. The other half of the sky, a little more than half, the other half of the sky is seen from, obviously, the Southern Hemisphere. And one thing we cannot see from here are the Magellanic Clouds, which are the two companion galaxies, of several, as it turns out, that are around our Milky Way. There is a dwarf galaxy out there as well. I think that might be is viewed through when you look toward the constellation of is it Cetus? Maybe, I don't know. Yeah, Cosmo says, you're telling me a professional astronomer named a nebula Spaghetti? Well, you have to understand that there's a lot of colloquial names for objects in the night sky that have been made. For instance, if we come here, okay, Cassiopeia A, it's an SNR, supernova remnant. Okay, that makes sense. You can understand that. Okay, but if we go to like the Sol Nebula is this nebula right here. We looked at that the other night, and it says it's the Sol Nebula. However, its real designation is Sharpless 2 199, or IC for Index Catalog 1848, or LBN for Lynn's Bright Nebula Catalog 667, right, and so on. So obviously there are some interesting names, and some of them are just colloquial. They're not meant to be real names. And this program here is the way we find things. There's the Bubble Nebula right there. Okay, we have the Salt and Pepper Cluster. Okay, but it's salt and pepper. They call it the Salt and Pepper Cluster, but it's really otherwise known as Messier 52, M52. So there's just common colloquial names that people give them. And
the common colloquial names are often what they look like.
Yeah, that's right. That's right.
Jeez.
But the Sol Nebula doesn't look like a soul, because we don't know what a soul looks like. However, another name for the Sol Nebula, believe it or not, and it's just kind of funny, Daryl, it sort of showed up. I don't remember this being the case, but here, the Sol Nebula is also known online, if you look it up, as the Baby Nebula. Isn't that interesting? Because we've talked about many times how this looks, I felt like it looked like the Star Baby from 2001: A Space Odyssey, and you said it was what did you call it? The Star Baby.
Yeah.
And it's called the Baby Nebula in some literature.
I remember that.
Yeah, it's fun. Okay, so right now we're at Cass A. We're going to just go for a little longer here. Let's go back and see. Yeah. Oh, yeah, we're pulling in some detail. I'm just going to double it up here. We've got 24 shots here. See, we have 24 shots, but you see it's kind of noisy. That noise is digital noise. That's the background. And to make the object you want really stand out, you've got to literally go twice as many exposures to get half the amount of noise. That's kind of a rule of thumb. You know, Daryl's giving you the name of the server directly if you want to go see where the server is, where all these images are landing. Because when we hit save, okay, this is where they go. Let's see here. Yeah, we don't want this. This isn't that. Okay, this is going to be Cassiopeia A.
Darn, I went back and looked at my history for the last 24 hours. I still can't figure out what I was looking at.
All right. All right, we'll save it. We got that one at 25. It's pretty faint, you know, and with a larger aperture, we have a 10-inch aperture out there. That's 10 inches in diameter. That scope right now, that's up to about 250 pounds out there right now, maybe 300 pounds, because it's on a pretty heavy steel pier, and so we're going to be putting this scope at some point. This scope's going to leave this desert where we have a beautiful sky, as you can see right here. This is our nighttime sky right now. There's the summer Milky Way beginning to set. Okay, there's a plane. You can see the flashing lights. But okay, here's the Pleiades coming up right here. All right, and Orion is rising here. See that? There's the belt of 3 stars. Let's bring it up this way so it's a little more obvious. Okay, and we bring up the constellations. You can see, okay, we have Deneb and Cygnus the Swan over here, and Vega over here. We have Deneb, we have Vega, and we have Altair. Okay, and Altair is down here. So these 3 stars make the summer triangle. All right, and the summer triangle is what you look for when you're looking at the summer sky. All right, so here's Deneb, here is Vega, and here is Altair. So that's the summer triangle, these 3 right there.
I found it.
What was it?
The Galactic Anti-Center.
Wow.
It's actually up this time of year. I don't know how I came across that.
That's funny.
It was linked to something else. If we know that the center of the Milky Way is off the tip of the spout of the teapot, Sagittarius A star is the black hole center. If you go 180 degrees across the sky, instead of the center of the galaxy, you're at the anti-center of the galaxy. That would be if you do a straight line from Sag A star through planet Earth, the direction the line is pointing is the other way. And that's the point that's between... can you go back to Starry for a minute?
Sure.
Back out. Okay, find Taurus. It's up now. Okay, there's Capella.
There's Jupiter. There's
Yeah,
Taurus.
and if you see right between the horns, the tips of the horns, zoom in a little bit that way, a little bit. Drag Capella and Auriga up.
Yeah.
Okay, there's Jupiter on the right. The star Elnath there near center. That is not only one of the tips of the bull's horns. The other star to the lower right of it that Mark is pointing at is, I believe, Zeta Tauri. And Jupiter's there. You see, those are the horns going back to the Hyades star cluster there where Aldebaran is. That's the bull's head right there.
Yeah, you can see when he...
And the galactic anti-center is right there near Elnath, which is also in the constellation Auriga the Charioteer. In the general area there between Elnath and Zeta Tauri. Zeta Tauri is where the Crab Nebula is.
It's it's off the end here.
In that general area is, if you do a line in space from Sagittarius A star through planet Earth, this is the direction that that line is pointing to.
Yeah.
So sorry about that. At least I figured out why.
No, I'm glad you did. It's all
talking
good.
about.
Yeah. Here's the Crab Nebula in Taurus right there.
Yeah.
Okay, now that's this object that we've seen a number of times. Okay. Our scope shows it so much better than this, and so if it's up, you can see the angle of the lines here. The lines have to be about horizontal for us to have it up high enough for us to see. You can see it's right near the horizon. Now this is rotating this way. Okay. And if it's horizontal, then it means we can see it because we can see the North Star, which is right there, from our telescope. Right, so if it's horizontal, we can catch it. If it's just below horizontal, we might be able to see it.
Sure. It's still early. Hopefully we get a look at it tonight.
Yeah. Yeah, and we got a bunch of things in Auriga that are beautiful to look at as well.
Yeah. Capella and then Callanan.
Yeah.
LNF on the other side. Why the horns poking the charioteer, I have no idea.
Don't know, because maybe he's being gored by the bull. All right. We can look at the Pleiades, and we will do that as well, so people can see the dust cloud that theoretically we're actually in. It seems that maybe we are within the Pleiades dust cloud here, which is kind of interesting to think about because, you know, the Pleiades are, gosh, a few hundred light years away, right? And we've got, you know, a dust cloud that can be many light years in size, and then we might be in that same dust cloud. It's ongoing research right now, actually.
When you see, heck, the Pleiades are high enough now.
Yeah, they are. We'll check them out after.
When
And
you see
California
the Pleiades,
Nebula too.
when you see the Pleiades, they're the second closest star cluster to Earth, thought to be. They're about 400 light years away. And down below them, there is the Hyades, which is, as I said earlier, forms the head of the bull. It's kind of a big V-shaped cluster.
Right.
And it's thought to be the closest star cluster at about 170 light years away. When you see the bright star Aldebaran in the horns, in the head of the bull, that's the bull's eye. It's actually a foreground object about 70 light years away.
Yeah.
So if you go out and look up in the sky at those, you can get a very three-dimensional view. Like seeing Jupiter there, it's maybe it's less than a light hour away from us.
5 astronomical units.
And then you see Aldebaran is about 70 light years. The Hyades there, the whole V of the Hyades is a cluster about 170 light years away. And then a little higher up and farther out is the Pleiades.
At 400 light years.
400 light. I've done this. You stand out there and, you know, you try to feel your way out there with your otherworldly form or something. You can get a very 3D feel for that. You know, how close Jupiter is and how far away the Hyades and the Pleiades are. It's like seeing a 3D, like you're looking down railroad tracks.
All right, well, we'll let's see what we got here. This looks like to be about the best we'll get tonight. I do want to mention, though, that there's a couple of things to also know about what we're doing, and that is that on this view here, okay, we do have a number of let me think here. I'm doing 10 things at once. There's a number of parameters here that you want to be familiar with, okay? And when we look at, for instance, the screen, when we're looking at the screen here, let me give us a thing here. This right here, this is our telescope control. This is our telescope computer right here. Obviously, this is the telescope view in the building from 2 different cameras. This bozo, that's me in Connecticut. This is 2,600 miles away in Arizona. Here's our main view. This is our stacking screen where we actually build an image sandwich and just stack images on top of each other. And this will give us the ability to remove noise. That's why these filaments now look so beautiful in here. Okay. Then this value here is our exposure. That's one of the most important fields on the screen. And the next most important one is gain. So we set the sensitivity of the sensor here. It can go all the way to like 600. And this is how long we're going to expose that sensor to the sky. And that gives us the precise combination of characteristics that we want to use on the camera to get the best shot. All right, so that's how we do things here. Let's do one last zoom. Let's see what we can see for detail on this. There it is, Daryl. Look at that. That's not bad.
Cassiopeia.
Yeah, it's not bad. Let's see how much more is in there hiding in the background.
There's a star conveniently near the center of that circle.
I see it. I'm wondering, I mean, this star?
Yes.
Yeah. If it was gonna be a star in there, it'd be a neutron star. And if it was a neutron star, it would be markedly more blue than the stars around it. So I'd wonder whether it went to a black hole or not. But that might just be convenience, as you say.
Yeah.
Well, very cool. All right, this is 43. We're going to save this here. 43
I
shots
saw Cassiopeia A.
for the first time ever. It's faint. All right. Well, that's going up to the server now, guys. So if you want to bring it down, you can see it too. The actual image that's going up there is this one right here. And this is the whole field. And right here is Cassiopeia A. Look at the ring. You see it with this extra filament out there? It's got a lot going on there. All right. And what we do is we process them to the point where we actually remove all that modeling noise and we make them look really, really pretty. That's one of our claims to fame, is that we provide that to our Patreon users that want to donate to us. So it's pretty cool. Okay.
This was the first supernova seen after Galileo turned the telescope toward the skies.
Wow.
Unfortunately, if they did point a telescope at it, I have never seen any word of it. This was still early on, though. And this is the last visible supernova to the naked eye in our Milky Way since then.
And Crab Nebula was 1054 AD, so a long time before that.
Yeah.
Wow. Okay. So let's go here now.
1600 something, I forget when.
Let's go to the Pleiades first, just to get a rough idea. It's currently at an altitude of 49 degrees, which is just above our limit with this side wall of the building. So we should be able to see that. Here's the telescope going there. You'll see it right away when the stars come in, because you're going to see this really bright set of stars coming in. I'm just going to change that there. Okay. Okay, oh, there they are. The Pleiades have joined the party. That's Alcyone up there. And what we'll do is we'll bring them down into the view. Here we go.
When you see the Pleiades, the Seven Sisters, or Subaru as the Japanese say.
Yep, just like the car.
These are the daughters of Atlas, the guy who carried the weight of the world on his shoulders. And actually, Atlas is in here amongst the Pleiades, plus his, I guess his wife,
Pleione,
yeah.
Here we have
So mom and dad are in there too.
Atlas and Pleione right here.
Yeah.
Interesting thing about Pleione, it's a rapid rotating star. So we think of stars as round balls of gas, right? Well, Pleione is actually really, really oblate, like an egg. It's spinning so fast that its equatorial diameter is much, much larger than its north-south diameter. So it's really, really a very rapid spinner. And if Pleione were to go supernova, it would have a very characteristic looking outflow because of that rapid rotation. We've seen that a lot in astronomy. Lewis Taz with us. Hey Lewis, how you doing? Yeah, there is a beautiful view. Let me take us eastward just a little bit. You'll notice when you look at these, it looks like, you might ask, gee, are we looking at it through some clouds? And no, we're not. We're actually looking at it with the telescope that's allowing us to see this faint blue haze around the stars. And that faint blue haze is dust that is scattering the blue starlight from these hot blue B stars. They're B-type stars. Let me move west a little bit.
You'd be amazed how many people on Reddit post the Pleiades night after night this time of year. It's gotten to the point where there is a subreddit called It's Always the Pleiades. People catch this thing on their cell phones. They don't know what they're looking at, so they post it up on Reddit. What is this?
Yeah, that's right.
And it's always the Pleiades.
Yeah. Yep. And as Calabo says, please remember to like and subscribe so you can get news and hear about future events. And most importantly, our giveaways. We do give away equipment. If you go to here, skytourlive.org, right there on our screen, and you scroll down, you can see all the past winners. One of the past winners that we're trying to get in touch with is Creamers. Another past winner is Richard McFarland. And neither of those two have responded yet. So hopefully they can do that before long, because I would hate to see them, lose out on the winnings that they actually deserve. They're winning each a pair of binoculars because they were in the chat that night. So let's do a time exposure, show you what's really hiding here. I'll start with a 10-second exposure just to show you. All right. And in 10 seconds, you're going to start to see something interesting happening here. Okay, let's clear this.
Oy.
I know. All right, here we go. So, this is the Pleiades that we all know and love. Okay? However, if we actually do some processing, we'll see that the Pleiades has something else going on. We see this dust, and if we actually do a color correction here to get rid of the blue haze cast, now you can see very clearly what's going on. There's dust around these stars. And what's happening is this. These stars are orbiting the galaxy. They're moving around the galaxy all together at the moment. Okay, they were formed in the same location. And after being formed in the same location, they had motion, they're moving, their dust cloud they were formed in was moving. And then they left that dust cloud behind. And now they're moving through a different part of space that just happens to be dusty. And it's 400 light years from us. And those stars are giving off a lot of blue light. And the dust that's all in here is scattering that blue light. It loves blue light. It's the dust is blue for the same... The light is blue for the same reason our sky is blue. The molecules in our atmosphere are scattering the blue light coming from the star because it has red, orange, yellow, green, and blue light. And same thing here. It's doing the same thing. Okay, let me raise my full width half maximum.
Uh-oh.
No, it's okay. I was just doing 10 seconds, and at this location, the filter needs to be a little higher. The stars look good. So, there we go. No, I think that the full width half maximum is consistently this high. It just happens to be, for where we're looking in the sky, it just happens to be over 10. We want that number to be down about 6. So, it might be windy, but I don't know. The wind would go up and down, and this is pretty consistent right here. All right, here we go. Yeah, see, it's all over 10. It's kind of in that region. But we can have these different values and still get round stars. It just depends which way the telescope's pointing.
Yeah.
Well, there you go.
In fact, you can see diffraction spikes on the stars. Says that you're spot on.
Yeah. Now, the other thing, too, guys, you'll notice, you can see this nebula right here. We'll zoom in on this to show you. These halos are artifacts of our system. We get rid of those for you when we do the highly processed versions. But if you look at this, you see this kind of looks like it's brushed like streaks. This is what's called the Merope Nebula, and of course, this star is Merope. This is Alcyone and Atlas and Pleione out here. This is Merope. Okay. Then up here we have Maya, and this is the nebula that is the dust cloud that's around Maya. Right. Currently, Maya is moving through all this as these stars are moving through this dust, and their gravity does deform it a little bit, but we are also getting the beautiful scattered light, and that's the blue light.
If you ever view the Pleiades through the eyepiece of a telescope, a nice low-power wide field view, the nebulosity there has a very combed appearance to it, like you've been hitting it with a hairbrush.
Like that.
And it really stands out.
Yeah, we can actually show that a little better now. All right. Also, I wanted to mention that the Pleiades is not just the 7 sisters. There's hundreds of stars in the Pleiades star cluster.
They say 1,000 stars now.
Yeah, okay. I can believe that. Let's
The
move up that
Pleiades is
curve.
one of those things, if you're in a decent sky and you look up, you'll see the stars. If you avert your vision a little bit, you'll see a foggy patch of light there. And what you're seeing is all the dust and all those thousands of stars, the lights,
Right.
the light from those 1,000 stars, and all the dust. It's about the size if you have a postage stamp in your hand at arm's length. It's about that big in the sky.
Yeah. That's a good analogy. So you can see all the objects that are within the Pleiades, the stars with their nebulous details. We have the Merope Nebula is its own object. Okay, the Maya Nebula up here is its own object right here. Okay. And so that's pretty cool. So
One of
we'll
the
just...
prettiest things in the sky.
It is. It is. And then we're going to save this like this is, so you can have the annotation so you can read and see which stars are which. Okay. We have Asterope. Yeah, okay. So I saved it, so that'll be out on the server too in about 30 seconds. But, you know, if you want to see it how you might see it in a telescope, let me try and do this. Let's pull this here. Okay. And then let's move this down here. A little more. So you might see something like this. But you won't see it in color. It's going to look like this to your eyes right there. This is without color. This is black and white. And this is how your eyes are going to see it. With it.
See more than that.
You're not going to see the nebulous detail, though. You're not going to see the Maya Nebula.
Oh, I beg to differ.
I don't know. I've looked at it many times with the eyepiece, and I've never seen the nebulas unless I actually took a photograph. I mean, if you're talking about up in Leadville, well, then I can believe it, because you got to have really dark skies to see these nebulae, don't you think?
Maybe I got spoiled up there.
I think you did.
But no, it was. I mean, it was quite. It was more like that.
Mm-hmm.
What I could see in the eyepiece.
Yeah.
It was, the nebulosity was notable.
Yeah. Well, when I was using just binoculars and a direct visual view of the Pleiades here in the desert, you could see it like I just showed you, where it was kind of like this, where you actually had some of the nebula there. Like more like you could see this. You can see that with your eye, and that's with the view we have now out there. If I bring this up again, okay. Okay, this glow here, this is Phoenix, about 75 miles away. Yep.
You okay?
Yeah, I was coughing. Yeah. So this is Phoenix, about 75 miles away. And with the sensitive camera, that's the the night vision camera we're using for our all sky, you can see it. You don't see this with your eyes. It's not visible to your eyes. And the sky here, when it's cloudy, you'll see clouds illuminated from below right up to about here. Then here they start getting darker and darker, and here they're black against the sky. So you literally watch the difference between what's called a Bortle 4 and a Bortle 3 sky right before your eyes. It's the way the sky is rated. Bortle 0 is like absolutely no light pollution. But even in places like that, you still have light pollution, and it's caused by the sky itself. It's called air glow. Well, hey, that's what we have here. That's what we're looking at. And right now, we're looking right here at the Pleiades. Okay. Now, our telescope has a range of views that it can see right now because of the walls of the building. So this is just above the wall of the building. Maybe some of this is above the wall. We'll check. There's
You see
Jupiter.
Jupiter, there's the Hyades, there's the Pleiades.
Right there's the Pleiades, yeah. All right. This is Capella, and we have Auriga.
Yeah.
And here's the kids, right here, the kids, actually.
Yep. The
Right here.
just below Capella. Capella is the goat star, and the constellations are Auriga. And what a goat has to do with the charioteer, I've never understood. But when you see the artistic portrayal of Auriga, Capella is his head, I believe, and the three little stars in the triangle there, the kids Mark mentioned, those are baby goats that he's holding in his left arm, and he's driving the chariot, facing right.
Yeah. Just another thing too, for people to understand, at our current site where we are, it's protected land, so we can't have any visitors. However, in Benson, where we're going to have this telescope eventually, and the current new one we're putting in, you need to understand that site is not, and we can have anyone we want out there. So if there's somebody local to Arizona who wants to come out and spend the night, if we're there, and hang out with us, we'll be happy to do that with you. That'll be
cool.
fun. Yeah, and you can come out too, Daryl, obviously.
I'd have to go to Arizona first.
Well, yeah.
Well,
Carbon Star says, "Hey Mark, what do you think about some of these new imaging stacking smart scopes coming? Okay, like the C-Star and some of the others that are out. I think they're great to get people into astronomy, and I've seen some people say, "Wow, check out my C-Star images; they're beautiful," and they are, But the only problem is the limitation with scopes like that. For $500, you can go out and take a picture without doing and knowing anything. You can just say, "Hey, I want to check out the clouds around the Pleiades," and you can do it with the C-Star. Okay, but the C-Star is this big in diameter. Okay, our scopes are this big in diameter and getting bigger all the time. So you have a problem with resolution of the objects you want to see because of the diameter. The bigger the diameter, the better resolution you get. So subtle details in these clouds, like when we look at the Maya Nebula here, we zoom into the Maya Nebula, you can see, look at these subtle banding and stuff going on in here. All this subtle, these little filaments right here. All this stuff, you might see this with C-Star, but you're not going to see a lot of this other detail in here. You'll see some, but you're not going to see some of the other details. And that's precisely because your diameter of your objective lens, the objective, is just not big enough to provide you a good resolution. And there's calculations that I could show you, and Daryl could show you about resolution. That'll show you all that. But you're just not going to see with the same amount of resolution. But let me tell you, if you've got $500 burning a hole in your pocket, go buy a C-Star. Take it with you on vacation. It's small. It fit in a suitcase, for crying out loud, and or it's in its own case. So I think that was pretty cool, and so I think it's an excellent way for people to get out there to see what's hiding above their heads.
There is a jump from the C-Star and similar small smart telescopes. Now, Celestron came out with what they call the Origin series. It also is a self-operating stacking image telescope system. Theirs uses a 6-inch diameter telescope, if I remember correctly. And good grief, the system is like $5,000 or $6,000. And actually, I mean, it will do tricks. It'll run circles around the C-Star 50, but it's still ultimately a very limiting system because you're locked into what Celestron gave you. You can't make any changes to the system that I know of, not yet anyway.
You do have filters though that you can swap out.
Yeah.
They come with filters which will allow you to get rid of some light pollution, but there's limitations. But look at this. Look at the Pleiades. Look at this dusty, filthy, dirty region. I mean, this hasn't been vacuumed for years. Okay. This room is a very dusty room. So you can see how much dust is here. And let me color correct here again. It's probably not going to do that much, but it did. That's good. Right, so you see we got a lot of detail in here, and if I pull these two bars together, it accents the detail even more. Here's that brushed look that Daryl was talking about before. You see, yeah, it looks like a combed view, combed detail here. See, it looks combed, and that's what's going on there.
Fantasy asks, yes, they're called the Seven Sisters. Yes, most people see 6 stars naked eye. Some do see 7.
Yeah.
I've seen talk, has something physical happened to the Pleiades that we don't see 7 stars now. I don't know of any supernovas inside the Pleiades. I think they're probably too young for that. I don't remember the stellar class offhand. They are
B-type stars.
Yeah. I would think if there was a supernova remnant in the Pleiades, we'd certainly see it.
Yeah, no, there's been no supernovae there as far as we know. I should actually say, within our knowledge, there hasn't been. We don't see any of that. So it's possible that at some point one of these stars could be massive enough to go supernova. We'll check it out. And I want to say hello to Crystal Ducote. Hi, is it Ducote or Ducote? I never actually found out. Crystal and her husband Ross they're here from Louisiana. I met them both out in Phoenix when we did the boot camp. They were members of our boot camp. Great to see you guys both here. Thank you for coming. I'm glad you could join us. I'm glad you got the alert. I'm glad you joined up. Check out the Pleiades, guys. These halos, again, those are just from our optical system. We can get rid of those. Really cool. Very nice. All right, we're going to do one more exposure. It's going to end right about now. There we go. We have 80. We're going to save it now. And we'll be done with the Pleiades. And let's go check out something else that might be available to us by now. Okay, we're going to go to our low light mode. All right, this is it coming up. All right, so
California high enough?
Yes, it is. That's where I was going.
Okay.
It should be. I mean, I looked at it the other night, and it's really cool. Fantasy says he camps on the California side, and so he would have no problem driving to the Benson, Arizona location. All right, cool. Well, we can have people there. That's the nice thing. I can have a star party there if I wanted to. Irish Beach Boys with us. How you doing, man? Good to see you. Very nice to see you, actually. It's nice to see you. Yeah, good, Ross. I'm glad you're here. Okay. Ducote. Okay, thank you for adding that for me. Thank you. I kind of thought that's what it was, because that's what we were calling you at the boot camp, and you didn't complain, so I guess that was right. All right. So the Pleiades are wonderful. They fill our field. By the way, our field of view here is 1.5 degrees by 1 degree tall. Now, it used to be 2.5 degrees by 1.5 degrees tall. We changed cameras, and we tuned the camera to this telescope specifically, so that gives us a much better arc seconds per pixel. Arc seconds are the resolution, as we were talking about, per pixel of camera, and we have a much better resolution now. And that camera is perfect for this telescope, so that's why we put it on. There's the 183 MC Pro by ZWO. Okay, so we're good here. Let's go now to here. I did not want to do that, but that's okay. We are at SkyTour Livestream West. And...
Don't do that.
Huh?
I said don't do that.
I know, right? This might... Where's the California from here? It's down, isn't it?
No, I think it's up.
Okay, that's even better. It's up here, right? There it is. Okay, good. Yeah, nice. So the California Nebula is right here. And we're going to actually go to that because this is a beautiful nebula. Let's see if I've got it in here. This has all my ones that I've added. It's not in there, but I'll add it and it'll find it. There it is. California Nebula, right there. So we're going to tell it to go to the California Nebula. We'll check our focus.
It's quite close to the Pleiades.
It is, yeah. All right, away we go. Look where the telescope's pointing. It's hovering along the top of that, right there. Okay, there's the star right there. That star is powering the nebula that's right here that you can't see. Okay.
The star's name is Menkib.
Menkib is right. Yep. Menkib is a very hot star. And if we zoom in a little bit here, you can see Menkib, as Daryl just said, right there. Menkib is a bright star. It's spectral class. Let's look for its spectral type here. It's 07. 07.5, but it's a Roman numeral 3. So 07.5 is the color. That means it's exceedingly blue. Most of its radiation it's giving off is in the ultraviolet. And then there's a luminosity class, which has to do with its evolution. A star that is fusing hydrogen to helium has a Roman numeral 5, a V, after it. Our sun is a G2, 5, Roman numeral 5. So the G2 is where it is in the G star classification, and then the 5, the Roman numeral 5, is its luminosity class. That means a normal hydrogen fusing star. Okay, that's what that means. All right, so in this, as we're looking at this, Menkib being an 07.5 star is literally one of the hottest stars that are out there in the universe. And these really, really hot stars will tend to put out a lot of ultraviolet energy, as we said, and that ultraviolet energy is intercepted by hydrogen atoms that are floating out here, and several things happen. The electron jumps up off the atom because it's absorbing energy from this hot star, the ultraviolet energy, and they collide with each other and other things out there, and then they fall back into the atom and give off this red light that you see, and we'll see that in a moment. However, the other thing that happens is these stars have powerful stellar winds, and you'll notice that this is going to be a curve. Menkib is actually shaping this nebula as well. Its solar winds are pushing these hydrogen atoms further away, and also building this shape. So there's Menkib, and what I'm going to do is I'm going to put Menkib down at the bottom here. All right.
Menkib is over 12,000 times as bright as our sun.
That's pretty darn bright, man.
Very energetic, which is why it's lighting up the nebula the way you'll see.
Yeah, so now that we know this, let's go and do a 25-second photo. And by the way, the fact that we can do 25-second photos and show you things that you should normally take 4 to 6 minute photos of is because our telescope is 25 times faster than its native configuration when we bought it. Okay, we added a special hyperstar lens from Starizona to actually make this telescope run not at the f10 that it used to be, but at f1.8. So for those who are out there that are photographers, it means that we actually run much faster photographically, so we don't have to make as many seconds of a long exposure to get this to be a beautiful image. So you'll see a 25-second image here in our stack. This is the previous one we shot with the Pleiades. That was saved and it's up on our server right now. By the way, this bottom part of this Merope Nebula was very, very, very faint on our past camera. With this camera so well tuned to this telescope, it's blaringly obvious. Hey, Judy M. Okay, let's check out the California Nebula. Alright, there's Menkib right there. Here's the California Nebula. You'll see these are our curves, okay? Red, green, and blue. First thing we'll do is correct the color. So we line these curves up under each other. So now it's color corrected. But you'll notice it looks bright. Well, this is our mid-level. This needs to go further off to the side of the peak. And this is our black level. We move this up toward the peak, but not surpassing the peak. And this will give us the darkest background. It's the black level. So now look at that. Notice the color, Daryl. This is very different from the oranges of this past, attempts.
You fixed it.
I did.
The reds are red and the teals are teal.
You got it. The oxygen 3, the doubly ionized oxygen, is teal like it should be. We don't see any of that here, by the way, guys. So this star is illuminating and causing this to glow. I could move it out of the view so we could see more of the nebula, though. Should I do that? We only have 3 shots.
Yeah.
All right, but let me just point out one thing. Notice that Menkib here, look at this gentle curve. See that curve? In part, that's because Menkib's intense ultraviolet radiation and stellar wind is pushing that stuff away, radially, away from itself. So it's carving a little curve in the front of the California Nebula. All right, let's now go and come out of here for one more second. And let's just move this to get it slightly out of our view. Let me actually do it this way. 1 second here. And then give me... There we are. Okay. So we're going to move up, up and away. And we'll move a little bit to the, right there. It's okay. I'm going to move to the west now. Okay. Okay, and then I'll just move up a little more. Hey, Cosmic Flow, how you doing? C&D boy, what's happening? Text 9, what's going on? Yeah, from Salt Lake City and Snowflake, Arizona. I mentioned last time I was in Snowflake. Okay, there's Mankib there. We're going to keep it just out of the shot. Alright. This is an extensive object. You know, several degrees in size. Thanks, C&D. William Connolly is with us. Hey, William. Nice to see you, brother. Alright, now let's go back to... we're going to do a 25-second shot again. And our telescope is going to be searching for a guide star, and it found one. You see these numbers just searching. When it actually finds a guide star, you'll see the numbers start. There we go. Their calibration starts at 0. And we're going to clear this one because that's the previous one we shot. Excellent. Text 9.
Hopefully we'll see why it's called
Lex.
the California Nebula.
That's Lex. What am I saying? Text. There you go.
I see Monterey.
Is that right here?
Yep. Oh yeah, right there on the point.
Yeah, right here.
Yeah. That's Monterey in the California Nebula, folks.
That's funny.
LA down there at the lower left.
Yep. It's a very extensive nebula, and this will actually give us a really nice view of it. Notice with our second image, it got sharper and brighter, just like that. Now, every time you double the amount of exposures, you have the amount of noise from that previous one. So, at 2 exposures, if we zoom in, okay, you see this modeling. This is digital noise, and we want that to go away. So now when a third exposure comes in, you'll see it get a little more diminished, okay? And so now we have a little less noise. Now, there was an actual noticeable result. So to go from 2 to 4, we should have about half the amount of noise from what we saw, roughly. You need lots of samples to do that, but I'm giving you a rough rule of thumb. Now at 4, when we come in, maybe you'll see a little change here in a sec. Watch. All right, see that? It got a little more subtle. And then we zoom out, you'll see that it actually looks pretty good. And we only have 4 shots right now, but if we can actually go here, what I'll do is I take the mid-range, and if I pull it down here, it'll soften a lot of that noise, even though we only have 4 shots. Okay, this noise is now really softened. Now, yes, the nebula is less bright, but over time we can pull this in more and more and more, and we'll see. Okay, like this is a good result right about here for now.
I see a fire-breathing dragon's head.
Oh yeah, there's the eye.
That's the eye.
Here's the nose.
No, the nose is at the far left.
Oh, you're seeing it that way.
And the flames are streaming down to the lower left.
Oh, that's funny. Yeah, with the mouth open here.
Yeah, and that bright thing there is his lower jaw.
Yeah. That's funny. I see Clifford the big red dog. Here's his bridge of his nose. Okay, here's his head, here's his eye, there's his ear. Okay. And I don't know what this is. Maybe he's getting sick. I don't know.
Stop that. I see Elsie the cow now.
I remember Elsie. Look how bright that gets. Wow, that's something. Nice.
Goblin sees a shrimp.
Yeah, I can see that too. Calabos, thank you so much for coming by, Mike. It was so good to see you. I know you got to get up early tomorrow. But hey, let's talk soon, okay, brother? You have a good night. We'll see you. Yeah. That's something else. Yeah, let's
I see Drogon quite clearly.
who?
Drogon,
Drogon.
Game of Thrones, the
Oh.
dragon.
Oh. That's right.
He's belching fire.
Yeah. Okay. I will save the image with annotations. Okay. I mean, look at the colors. Look at how beautiful. And people, think that these colors aren't real, but they actually are. These are the actual colors. Trisha's from Whidbey Island, Washington. And Redondo Beach, Fantasy. In Torrance, okay, yep. Calabos is near Torrance. Yeah, very nice. Hey folks, thank you for wishing Calabos a good night. He's a real good friend of the channel and of me personally, along with Tiffany. They're really cool people. Almost as cool as all of you. This is pretty. So we're at 12 exposures. I'm not going to go beyond 15. I'll do 15, then we'll save it. I'll save it now as an intermediate. Now, one of the things we can do is if we're stacking and we get a satellite trail from a Starlink or something, I can click this here, unstack, and it will take that last stacked image and remove it from the stack so we can get rid of it, which is kind of nice.
You just figured that out.
Yeah. It's been there, and I just have kind of been ignoring it.
Well, good.
Torrance.
Learn something every day.
Torrance. Okay, Fantasy. Thanks, man. I need to go to Torrance. Kind of sounds like Tourette's. All right.
What else is in Torrance? I forget.
Celestron.
JPL?
That's Pasadena.
Hmm.
I was in Pasadena like 2 years in a row. I'll be there again this year.
Torrance is Celestron. I remember that now.
Yeah. I visited the plant. Got a nice tour. It was really nice. Back then, I actually saw the white rooms and clean rooms, where they actually did a lot of the optical testing and stuff. It was really really neat. Then I think they sold out the Shenzhenzi.
Don't get me started. This is about the only game in town now.
Yeah.
That makes me sad.
Yeah.
I am old enough to remember when Celestron telescopes were white and blue.
Oh, I remember when they were orange.
White and blue is back when they built great big, like 22-inch
Yeah,
telescopes.
the Celestron 22 was a very, very popular scope for universities.
And then they went orange.
Yep.
And then they went black, and
then they went white again. White and black.
And well, they're black, they're white, they're orange, they're all those colors.
Yeah, ours is black. The Celestron 11 we have is black.
Yeah.
All right. Okay, so there's the California Nebula. It does extend below down here. I was thinking, do we image it or do I just move on to another object? What do you want to do?
You should
Probably should image it.
You should mosaic that some night, maybe not tonight.
Okay. All right, so we got a bunch in there. And
look at your field in Stellarium. I bet you only caught a third of it.
Oh, yeah, about a third to a half, I think. Let me go look, though, like you say. Let's do this. Oh, Lullaby, Twinkle, Twinkle, Little Star. All right, so let's take a look here. Oh, wait. Let's get it.
Yeah, heck.
Yeah, so we were here. And so
Yeah,
we
about
got
half.
just about half of it. But there's something in this neighborhood that's actually pretty cool. I hope we can see it. That's not it, though, I don't think. Well, that's the northern Triffid. That's actually pretty cool. Another nebula that's neat. It's something we can access while waiting for some things in Auriga to come up. So let's go there and look at the northern Triffid. The Triffid Nebula, Trifid Nebula, however you pronounce it, is a 3-lobed nebula because it has 3 dark lanes in it. Those dark lanes are in front of the nebula that's glowing behind it, and it makes it look like interesting. Here it is right here. And we'll show you that in just a second. Let me bring it down. Northern Triffid is cool. Okay, and then we'll move eastward to bring it in. There it is. Let's keep going a little more. Little more, little more. Little more. There we go. Okay.
This is the little Trifid.
Northern Drive.
Northern. Well,
Yeah.
it's a little one too.
It is, yeah, that's true.
The real Trifid is the one Messier 20 in Sagittarius. Just
Yeah.
above Messier 8.
Okay, so we're gonna.
It's basically lost in the sun right now.
That's right. It's lost in the sunset glare too.
Yeah.
Okay, let's do a 25-second shot here. That's all we need for this.
Venus flew right through the teapot recently. It's past it now.
Mm-hmm.
The
Okay.
teapot's down between Venus and the sun.
All right, there's the California Nebula looking beautiful. All right, and that's saved up to our site. Go to skytourlive.org. Check out the links that Daryl listed, or go here and scroll down and you'll find it. Also, remember, we run on your donations and your support, so hopefully you can donate to us and help us out. Sorry about that. I guess I cleared it.
We need to talk offline.
Okay. So, let's see the Northern Triffid now. You'll see why they call it Northern Triffid, and there you go. It's got 3 dark bars of dust, which are between us and the bright nebula behind. So, it's a little bit smaller. The regular Triffid is about this big. This one is a little smaller. But it's definitely got some detail in it. And if we just let this go a little longer, we'll actually see it. And this will probably be identified. Let's see. Yeah, there it is. Let's actually do this. There we are. Okay.
So it's Cluster N Nebula.
Yeah, it's NGC 1579. And that'll be our target name. So I can tell it to be the target name, and it shows up there. All right, but I will also come up here and add to this. I'll add Northern Triffid. Okay. Here we are. And we'll save it with the annotations.
I think I see just a touch of blue around that top star.
Up here, actually, I think you're right. There is a reflection nebula here.
Actually, I'm at the star directly above the.
Oh, right here?
Yes.
Oh, well, there's some here, too.
Yes.
Now, if you want to see what's there, I kind of do this quick punch over process just to see what might be hiding. You can see there's a lot of dust in here. Okay. And we'll check that out in a little while when we get a little minute more. There's a lot going on in here. All right, so let's color correct this. Make sure the curves are good. They're going to be adjusted a little. Now you'll see lots of stars here. Then they seem to go away, and they come back. This is all dust. This is all dust in here. It's all dusty region. But somewhere in here, a star managed to form from this condensing hydrogen that's in there as well. And the star formed inside the dust cloud and from the hydrogen gas, and it's fusing hydrogen into helium. And as it does so, it's actually able to ionize the hydrogen gas quite nicely, and that's what's glowing red here. Things are falling down here. All right. I'm just going to wait for a few more shots to come in here while I message someone that's sending me a message. What's that?
Madden Kerr asked a question of you. What software is this?
Oh, Medenker, this is actually SharpCap that we're using right now. And SharpCap, written by Robin Glover, really good guy. I've given him some thoughts on the software, and he is he's very responsive. He's actually made changes based on the recommendations from folks. So it's really cool. Great software. There, see, now I bring this in a little, and now you can start to see this dust cloud taking shape. See that?
Well,
looking really good now. So we'll let that
go.
go.
See the dark stuff coming out too.
Yeah, like here.
Above it, below it, to the lower left,
yeah.
And upper left.
And now you can see why this star is involved too, because now you see that the dark dust that's in here is being scattering the star's blue light. Same with this star here. So we know that this star and this star are at the same relative distance, not extreme foreground or background stars, because they're part of this. They're in this dust cloud. But you see the lack of stars, and that's what the dead giveaway that you're looking through dust.
Can you zoom in on it some?
I can, yeah.
I know your notation said that there was a star cluster in there.
Yeah.
As in multiple stars.
Yeah. Let me make this better quality here.
ICXT has another question for you also.
Okay.
What telescope and camera are you using?
Well, the telescope that you're looking at right above here is actually a Meade LX600, and we've got a hyperstar system on it, which allows us to run 25 times faster. It's from Starizona down in Tucson. They're great people, good friends, and they actually installed this I installed it, but they made it specifically for this telescope, and it's up until recently we had the only one on the planet Earth, so there was no other Meade telescope. Meade LX600, it was converted to a hyperstar system that gives our telescope a much faster photographic speed of f1.8. So virtually anything entering the tube from outside is going to make an image because of the light. It's very sensitive now, and coupled with a very sensitive sensor, it's just incredible. You know? Yes, indeed.
Petita's here.
I saw Petita this weekend for like 2 days with her husband Woody. And Woody fixed my car. The guy just went outside and went like madman. He went to town fixing my car. The guy is a freaking genius. You know?
Who?
Her husband, Woody.
Oh.
Petita's husband. Yeah.
Connolly
Just
asked.
gonna ask you. Yeah, I saw that. Yeah. You want to answer first? I will. You can let you do that. Go for it.
William, it's star stuff. It's dust. It's carbon. It's silicates. Some gas, just mostly dust. If it's cool enough, it's not just atoms, it's molecules.
Mm-hmm. And ices too. Don't forget the ices.
And ices.
Yeah. So one of the things to consider here, and hey Luba, how you doing? I think that the dust itself, okay, it literally is, life begins in the dark. Okay, in fact, you guys hear the songs that I write for the show. You hear them at the beginning, at the end, and all that. One of the songs is called "Life Began in the Dark." You haven't heard that one yet, but this is exactly true. In these dark nebulae here, these are cold regions of space. Sometimes they're minus 250 to 260 below 0 Celsius regions of space. Absolute zero is minus 273, just for the record. So they're very cold, and so the dust grains are very, very tiny. They're micron-sized dust grains, okay, which is basically that fractions of a millionth of a meter. Okay, they're very, very tiny dust grains, and so these dust grains will attract ice, and will end up letting other material form on their surfaces and form like a little ice ball that contains a little slurry of planet-making material. And that's what these grains are made of. And these grains are in clouds that are light years in size. Okay? So in here, in this cloud, for instance, this is light years in diameter. But remember, it's in 3D, so it goes out, it goes into the page, it goes out, it's big, and it's filling this region of space. So there's an awful lot going on here. Let me pull out a little more detail even now. There we go. Now you can see the dust.
When you have a moment, can you go by Stellarium for a second?
Yeah, sure. Let me just, while we're going here, we got 22 captured here. Yeah, that's beautiful. All right, so we'll pop out into Stellarium now.
Back out some.
Yeah, sorry. How'd it go?
Okay. We're kind of looking along the galactic plane still, aren't we?
Yeah, I mean,
close to it.
yeah, I mean, we've got, okay, we have Triangulum here, okay, and to the northwest, we have Cygnus still up there, and it's coming down around here like this.
Yeah. And so you're seeing the dust in the galactic plane where the dust tends to hang out.
Yeah, there's another object I want to go and look at too after this one. And it's up in Perseus here. And it might be this. No, it's Flaming Star, sorry. It's the Perseus cloud, which is really quite a interesting cloud, and it's an amazing region of dust and everything that's just really stunning.
Isn't that what I sent you an APOD fairly recently of a really striking area of light and dark and clouds and everything? I don't remember what it was now.
Yeah, I don't remember what that was. Oh, is it this here? Yeah, okay, this is the Purges cloud. That's where we're going to go next. All right, because you see here, we have this here, okay, which is the California Nebula. Okay. And then right near the California Nebula is this Purges cloud, right? And it's a cloud of dark dust. It's dark dust, all right, that's actually got some light illuminating it, which is looks eerie, ghostly. But it doesn't have emission nebula in it. It's just dust because no stars had formed in there at this point, all right? And that is down here. Okay, the Purge cloud is down above, rather, this guy right here, which is where we are. We're looking at the northern Trifid right here. And that's something. Now, let me put us right where we are here. Let's bring up our field of view again. Okay, there it is. And let's look at this and make sure that we are pretty close. We are. That's good. All right, we're centered pretty well here. And this tool you're going to see here, this tool allows us to do measurements. And we're going to be able to measure sizes of the clouds and stuff using this and actually do some really cool analysis. That's something else we're going to do, but just not tonight. All right, so let's see if we can get a little more detail in here by pulling this back. You can start to see how soft and gossamer this dust is here. Gosh, it's pretty. Let's really punch it up. It'll be too much, but we'll check it out. All right, now you can see the glows around some of the other stars that are associated with this, and they actually have nebula around them too. They're causing their blue light is streaming away from them, and the dark nebula is scattering that light and making this subtle glow that we see here. Very cool. Let's do this. This is called a push process, where you actually move these curves kind of closer to each other, these lines. And so you get things that look kind of like this, okay, where it's kind of over processed, but it allows you to see some of the detail in here, like these dark patches that are in there. You know, and we can adjust like this and just say, okay, well, we can just bring it back to this, and this is sort of like the best noise ratio for the current moment that we're viewing this. And this is with 33 images stacked. That's good. That's nice. Northern Trifid has never looked so good. We've seen this before, and it really has only been this. We've never seen this out here until we managed to optimize the camera. Really nice. Very nice. Okay. And then from here, we're gonna, okay, we're there, that's good. And then I'm going to do this. I'm gonna actually synchronize on that. All right, let's see what's going on in the chat.
Star Voyager asked a question. Could there be more dust out there than we think, partially explaining dark matter? And it kind of all turns into cosmology questions from there going down the chat. You already know this, Star Voyager, I guess. Dust is regular matter, and dark matter is conjecture, pure conjecture.
Non-baryonic.
Thank you. Non-baryonic. I mean, we see its effects, but we don't see it. and we can't find it.
Conventional.
Yes, the whole nature of the non-baryonic matter is, I mean, we don't know what it is.
Yeah, it's seen indirectly in galactic rotation, because when galaxies rotate, they have those spiral arms you're familiar with. And at this point in the universe's history and evolution, we would expect that a galaxy's spiral arms will have wound up. But it doesn't work that way. We do see differential rotation to some degree, where the middle stars in a galaxy are going around it faster than the outer stars. Okay, kind of like Mercury goes around the sun very, very fast in 88 days, but Pluto takes over 230 years or so to go around the sun. So the farther away from the center of gravitation in a system, the slower the orbit is required. But one thing we noticed when we looked at the galaxies and how they rotate is that the farther away we get, you would expect things on the outside to rotate slower around the galaxy, so they'd lag behind and drag out. So the spiral arms should be all wound up by now. But we don't see that. In fact, we see some spiral arms that are kind of just loose. And what's happening is when you study the rotation rates of stars outside versus inside, you find that there is a difference, yes. But the difference is way less than predicted by the model. Meaning that something is helping those outer stars along to keep in an orbit in the outer part of the galaxy. And when they added a concept called dark matter to the equation, that explained it very, very nicely for how galactic rotation really works. Now that is the indirect observation of dark matter. It's not direct, as Daryl just finished telling you. So there's a lot of conjecture, a lot of reasons why dark matter makes sense. And dark matter is not dark energy. That's a whole different thing discovered by different ways. It has nothing to do with dark matter at all.
Yeah.
Okay. So the only thing is the word dark is in there, and it just means we don't know it, right? So there you go. We don't know what it is.
Yeah, don't get me started.
Well, we know neither Daryl nor I see. As an astronomer, I can tell you that I understand the concept of dark energy and dark matter. As a sensible science guy, though, I do have some problems with dark energy. Not necessarily with dark matter, but with dark energy. I don't know if I buy the concept 100%. It seems like a fudge factor to me, and I think to you too, Daryl.
Yes. I think there's a failure to understand or fit the data to the model.
I think that's true.
And somebody mentioned black holes, Lubo, I think.
Okay.
Actually, black holes would probably be the most conventional explanation for dark matter, stuff that we can't see by its nature. I don't claim to be an expert on it, but I think, to give the mass that we're seeing effects of but don't see directly, that might take an awful lot of black holes.
Yeah.
But this could go back to primordial black holes, that were created at the Big Bang.
Yeah.
There's a lot more of them out there than we know about.
Yeah. And we have discovered some rogue black holes that are all alone, moving through space. But then again, looking in a region of Orion, which is coming up, which we're going to see in the winter season here, there's a lot of discoveries that are suggestive that there look like there's rogue planets out there. Planets with no home system. They're just roaming through interstellar space. That's pretty cool too. Really neat. I like that concept. Alright, so here is our Northern Trifid Nebula. You can see the dust. Let's see if we can see what else is there. Let's overprocess it for a moment. Yeah, you can see There's a lot of dust in here and here. Quite a lot, actually. And that's just momentary. Another way to look at this is to do it as a negative. And you can see those lobes much better. We process it as a negative. In astronomy, we use negatives a lot, actually, the negative and inverse of images. I remember in black and whites like this. So I remember that many of the things I did in astronomy, see, now you can see those stars. You can see that blue dust around the stars quite nicely. So this star is involved. This star is involved. This one is. This one is. This one is. These are stars that with conjecture, we can say they're about the same distance as this nebula. In the dark,
They used
dark nebula.
reverse black and white a lot back in the day. I know the photographic plates, glass plates and such. Do they really do that so much anymore, though?
Yeah, actually, it depends. I mean, there's a lot of catalogs out there that are only negative catalogs. That is, you only get the inverse of the image. Like I have,
but those are older catalogs.
well, the AAVSO catalogs still have inverted images, and you can get plates right now, and say plates, digital images that are inverses. But with the advent of Hubble and James Webb, the public doesn't generally look at negatives. They tend to look at the positive, like pretty pictures. And so keeping the funding going means show them lots of pretty pictures.
Yep. What it is.
Yeah. And so that's what they do. And I'm so glad I'm not in that rat race.
That brings up the whole black hole thing. The black hole images, it's been a bit of a controversy lately that like what they showed us with M87 and Sagittarius A star, the Event Horizon Telescope. I mean, they're saying what they showed us may not really be what they look like.
Yeah.
It's the way they handled the data.
Exactly.
I understand it. They averaged everything, and
Yeah.
all it did was make a fuzzy-looking orange donut.
Yeah.
And I remember saying back at the time that, golly, if they keep looking at more black holes and they all wind up looking like the same orange donut, are you going to lose interest with the public?
Well, I will say this, okay? The problem is black holes close to the event horizon, material is moving extremely fast. So as the Event Horizon Telescope is taking images, the data is actually changing that they're getting, and the black hole is always going to be blurry because of that material that's moved to very fast speeds near its event horizon. And that's part of the problem, is that you've got rapid rotators that change hour to hour as far as a telescope's concerned. Even at great distance, they can still see a change, and that change also tends to make your image look fuzzier, and so you do tend to get a problematic image trying to take a picture of a supermassive black hole, because there are a lot of small changes occurring on the event horizon at all times. So that type of thing will definitely cause your black holes to be fuzzy. I remember reading a paper on this. They talked about the considerations for how you actually get an image of a black hole and why we don't see them sharp and clear. Anyway, I'm going to get out of this. This is 57. We're going to save it here for one final time. And then we're going to go to the next cloud that I want to look at in this region. Okay. So there we go. And this is the image you'll get when you go up there and check it out. It's going to be this.
High enough yet?
Yeah, that's what I'm kind of waiting. We're going to do the Perseus cloud first. So we got this. That's our finder. Right? And then we have the actual image out there as well, which should be this one. Let's 34. No, we're not there yet. We got a lot more. Okay, we'll find it. It'll be up there in a minute, about 30 seconds. Okay, so what we do is we're going to get out of this stack and go back to our low light image, our low light view. This gives us the ability to kind of take a peek at what we're looking at ahead of time. All right, we're kind of zoomed in a little bit, so we're going to go back and fit the width in. I'll do that like this. All right. I think I gotta go back to that guy. Okay. All right. So now we're gonna go now up, and we're gonna go to this Perseus cloud, so you can see what's going on with the Perseus cloud. This is cool because the Perseus cloud is one that's really neat. And it's right up above here. That's actually a planetary nebula. But above this, we have the Per cloud, which is, where was it? It was just up here. I just saw it. Where'd it go? There it is. No, that's even better. The Embryo Nebula. Nice. Here's the Perseus cloud. The Perseus cloud is, again, Dark Nebula, and then Embryo Nebula is another one. Well, we're actually going to skip to the Embryo. I'll tell you why. Because when you see the Embryo, it does have some really nice hydrogen alpha colors in it, as well as it has dark nebula that's really stunning. So we'll check out the Embryo as well. You remember the Embryo? We looked at this before.
The name rings a bell.
Okay. What tone was the bell? What frequency was the bell?
Ding dong, ding dong.
Yeah.
No,
Right.
wait, that was my ice cream truck.
Good humor ice cream trucks.
Wasn't good humor. It was a kitty cart ice cream company, and they had little ship's bells
Oh,
mounted
wow.
on the window frames, and we rang them with a cord. Ding, 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 ding.
Yeah, I remember that.
Ding, 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 ding. I used to be the ice cream man, people,
Oh, that's funny.
a long time ago.
Wow.
We
Okay.
drove open Jeeps.
Oh, is that what it was?
Yep.
Wow.
Open Jeeps with a freezer on the back. Had a hell of a suntan. Except for the back of my legs.
Oh, I remember those cars. Those were Jeeps, weren't they?
Mine were.
Yeah, because the Good Humor ice cream truck, it had like a freezer behind you. And you get out, open the little freezer door, and reach in and pull out the ice cream for the kids that wanted the ice cream.
Yeah.
Okay. Let's go and go do a 30-second shot of this guy. That's a 30D shot. I don't want that. I want 30 seconds. All right. All right. And then we're going to go into deep sky mode here. That's going to pull us here. Go to our live stack. That's just a beautiful image, and that'll be up on the server. It's probably already up there, but isn't that gorgeous? That's what's up there now. Okay, so we're going to clear that. Now you'll see the Embryo Nebula. It's going to look sort of similar. A little, obviously, some differences. Look at that. It's got more blue reflection nebula, where that starlight is being scattered by dark dust, but it has red components, some red stuff buried in more dust. It is just a spectacular location.
That's just the 1 second image.
No, 30 seconds. It's the 30-second image.
I see it now.
Yeah. All right. So let's color correct. Get our color correction going. So you'll see different bands of dark material that are illuminated, and then you'll see these amazing little pockets of red nebula, a red diffuse hydrogen alpha region nebula. We also call it H2, H Roman numeral 2, so HII, and that stands for singly ionized hydrogen. And the reason is because H1, just like oxygen 1 with a Roman numeral 1, is the base state where they have all their electrons. But we leave that off when we talk about oxygen and hydrogen and the other elements, so it's understood. So an ionized oxygen molecule, or atom even, is O2, O Roman numeral 2, OII. Okay, that's a singly ionized oxygen. Doubly ionized oxygen is OIII. Okay, and singly ionized hydrogen is HII, because HI and OI, for instance, are, again, the base state where they already have all their electrons.
Yeah.
It's like counting from 0 versus starting at 1. All right, let's see here. Let's pull this dark up the slope a little bit, get a little more contrast. This is a really fascinating region, guys. I mean, it's incredible what's going on in here. See this amazing shape here? That is like a stellar nursery going on in here, where stars are being born. And as we've talked about, we're seeing the universe as it was in the past. We're never seeing it as it is now. So this whole region could look very different right now. Okay, let's go to stellarium for a minute. The distance to this feature is about 4,000 light years away, and that's the embryo nebula. Let's go up here and grab that, because there we are. We're about 4,000 light years from the embryo nebula. So you're seeing it as it was 4,000 years ago. If we looked at it today, instantly could see what it looks like right now, then you might see some differences. But look at these beautiful pillows of dark nebula that are hanging out in here. It's just a gorgeous area, and these pillows are being illuminated by that star that are sending its light. Now, the starlight is being scattered by those blue particles of dust, but then when it gets here, it's a combination of scattering of the starlight coupled with direct illumination by starlight. So the scattering is falling off in the intensity because it's much less blue.
I saw one of the other names for it is, what was it? The Phantom Tiara?
Is that what it said? Oh yeah, look at that. The Phantom Tiara.
I mean, an embryo, I thought it was going to look like a fried egg or something.
Well, I think the embryo is this right here. Let's zoom in on that. Okay. It looks like this. See that? I think that's the source of the name.
This is one of those nebulas that reminds me of an old Gustave Doré etching or engraving. He was an artist back in the 1800s that everybody here has doubtless seen his illustrations if you knew who he was or not. It's like biblical engravings of, the clouds of heaven or something you're looking up into.
Mm-hmm. I think I've seen those etchings.
Oh, everybody's seen them. They're very well known. They just most people don't know where they came from.
Mm-hmm.
It's like, clouds of heaven, people marching up into the clouds, stuff like that.
Yep.
Dante's Inferno, all sorts of things like that he did.
Yep. Hey, JCO. JSU's with us. Fantasy, you asked a question earlier and I didn't answer it yet. I'm sorry. You said, do you think dark energy could just be some force we can't measure in our dimension? We're in 4 dimensions, X, Y, and Z, moving through time. So, I know what you mean, in our dimensions. And then he says, I mean, you can measure it, but what I mean is it's external force. It's external force that we just would never know in our dimension. You see, you're having trouble talking about it because everybody is. It's not just you. Let me tell you what dark energy manifests as. It appears that dark energy is a repulsive force. Pushes everything else away from everything else. How it acts is when you take dishwashing liquid, Dawn dishwashing liquid, and take a single drop, and you put water with streaks of food coloring, and as you drop a single drop of food coloring in, or Dawn dish detergent in, all of a sudden, everything is moving away from everything else in there. It's a really cool effect. We've used it in science fiction special effects, actually, when I was working with Doug Trumbull at the studio on our movies. And so when that process occurs in the universe, we can't identify that we're dropping Dawn dish detergent, for instance. We don't know what that dish detergent looks like. But it's causing a repulsive force. It causes everything to move away from everything else. Now, yes, we understand the process that makes dish detergent repel a dye that's in water. Yeah, we understand that. And it's not at all the same thing, but it's just an illustration of what we're seeing. Now, as it is, everything is moving away from everything else naturally in the universe. The best way to illustrate this is, imagine a balloon. You blow it up a little bit, make it the size of your fist. Take a Sharpie and put black dots all over it, everywhere. Okay, now you put that balloon back in your mouth and you continue to blow it up. Every single black dot is moving away from every other black dot on that balloon.
And the farther apart they are from each other, the faster they're moving.
That's correct, and that's the redshift thing that Edwin Hubble discovered in the 20s. Okay, so that particular analogy shows the expansion rate of the universe. What's happening is you have to blow more and more air into that balloon every second to have it accelerate and get bigger and bigger and bigger and bigger every second. And that acceleration outward is the thing that we can't explain. We can say, well, we just increase the airflow into the balloon and it'll make it expand faster every second. Yes, that's right. But increasing the expansion rate of the universe every second is what's happening. And how that's happening? Well, that's the mystery, and that's where dark energy came into play. They figured if there was a repulsive force that was causing everything to be moving away from everything else, then we could use dark energy as the reason why the universe is expanding at an accelerating rate. You know, it's like you go down a hill on a bike. If you just don't use the brakes, you're going to go faster and faster and faster every second until you're going to crash at the bottom. That's actually what happened to me on a street called View Street here in Plainville, Connecticut, 2 towns over. I went down without brakes on my bike from the very top, and I crashed at the bottom. But
Well,
go ahead.
we talked about this recently. I am not saying it's anti-gravity, but the end result is sort of like anti-gravity. Something is pushing everything apart more than the remainder of the Big Bang propelling things outward in the first place to the expanding universe. There's something else going on there that's pushing everything apart faster than what we expected it to be.
Well, that's true. But what is that? What is that force? Well, we don't know. But cosmologically, when you look at the expansion of the universe and we notice that it's accelerating, the only thing we can come up with so far is dark energy, this repulsive force. But let's talk about dimensions for a second. Maybe we're seeing an energy that's helping with this expansion that isn't coming from any of our 4 dimensions, X, Y, or Z, moving through time. There could be more dimensions. And some of these dimensions are explained in string theory. And let me just say what string theory is for those that don't know. First of all, we're familiar with particle physics. A proton, the nucleus of an atom, a hydrogen atom, an electron, another particle that's more like a cloud everywhere at once around the hydrogen atom. You're already forced to start suspending your disbelief about what an electron is by considering it a cloud rather than a single particle. So already you got to push your mind to go in down that route and believe that. However, what if we didn't think about particles? What if we thought about the fact that these particles are all moving? Okay, a proton in slow motion is actually vibrating in many different locations. It's vibrating. What if you could stop it at one end of its vibration here and then stop it at the other end of its vibration? The path it took to go into that, to do that vibration, what's that path? That path is the string. So it's kind of like you think of particles a different way. And this isn't an exact way to describe it, but it's a way, as an introductory way to describe what a string is. They're little tiny, infinitesimally small, and the thing is, the proton goes back and forth within our 4 dimensions. So it starts and stops in our 4 dimensions. So that means the string loops around, and it starts in our dimension and comes back in our dimensions. Excellent. Okay, so now electrons do the same thing. Other particles within the atom do the same thing. Other hadrons and leptons, all the different types of atomic particles, they all do the same type of thing. They start and they stop within our dimensions. All right. The thing that doesn't work right is gravity. Gravity, we can measure it. We calculate its force. Heck, we left the solar system using very, very accurate calculations of gravitational force, okay, to whip the Voyagers out of our solar system, get to Pluto in 10 years, by using gravitational, really circuitous routes to get to Pluto. But the problem is, when you look at, and this is coming out nice, by the way, when you look at the problem with gravity seems to originate here, and in terms of the string thing, but we don't know. We know what gravity waves are, and particles like protons can be described, and electrons can be described as particles, or they can be described with equations. You have a probability equation that you can figure out where the proton is at any one time with a probability within the atom. Okay, so that's called duality. You have a wave nature and a particle nature of particles, and that's what is the foundation of quantum mechanics, the study of atoms and so forth. Well, and atomic transitions. Well, the thing is, when you get to gravity, you're going to hit your head because, we know about gravity waves. We've seen them. We've calculated them. The Laser Interferometric Gravitational Wave Observatories, LIGOs, okay, and Virgo in Italy, the LIGO detectors detected gravitational waves hitting us from merging neutron stars and merging black holes, right? Daryl's talked about this with us as well before. So the thing is, these black holes, when they merge, we see the gravitational wave. We have not seen gravitational particles. So we can't identify the vibration to make the string. So we can't find the graviton. Now, that theoretically does exist. And it looks like it exists in one of these other string dimensions, namely a 5th dimension. Kind of like the band, right, Daryl? 5th dimension? Yeah. Well, if the gravity's in that 5th dimension, it means it originates here but terminates there. And this would explain why we can't see it. It explains why we can't see the particle. It explains why we don't see the looping string, like protons and all the others. All right. So that is why gravity is the oddball. So looking interdimensionally for other solutions, fantasy is a really, really good idea. And so that's a very thought-provoking thing you mentioned, because everything I just mentioned. Go ahead.
I think there is so much out there that we don't know yet. You're getting into some really basic, deep things. I hardly know how to express it. Did you see the recent pictures of somebody supposedly imaged a photon?
Yes, actually, I have.
Anton Petrov did an article did a video about it on YouTube, and Sabian Hostenfelder may have, but I've seen a bunch of stuff about it recently. And I mean, you're getting into the basic nature of light itself, and we have talked about this in the sense that there is no passage of time for a photon.
Yeah, right.
There is no passage of time at the speed of light. Time is, zero. And what does that mean? I mean, a photon could leave the sun and arrive at Earth 8 minutes later. To that photon, though, no time has passed at all.
I know,
and
you're right.
A photon could leave the sun and fly to Alpha Centauri and take 4.2 years to get there. Yet to the photon, no time at all has passed. And, well, that photon is at the sun, and then, bingo, instantly, that photon is at Alpha Centauri, or at a galaxy on the far side of the universe. No time passes. And that is saying something so basic that I think we haven't got a clue about yet. You're on the other side of something. And what all is out there on that other side, where light lives.
Yeah. That's very true.
Anyway.
No, that's a very good observation, Joe. Very good observation.
Well, as far as actually seeing a photon, that it looked like the image I saw looked like it had artifacts all over it. I mean, there were straight rows of stuff, and I wonder how much of that was anything real or how much was just artifacts introduced by however they managed to see the photon.
Yeah. Michael Hedrick's with us. Hey, Michael. Good to see you joined us. So that's the neat thing, folks. That's what we deal with in astronomy, is these types of puzzles and conundrums. This is coming out nice. Look at these little spindles here of dust that are in here. This is really pretty. This is going to be a beautiful image processed. Okay, we have 36. We're going to save it here. And this is the embryo nebula. Okay. Rascally rabbit. Is that what you were laughing at?
Yes.
Okay.
I answered danger, Will Robinson, danger.
You see that? Danger, Will Robinson, danger.
Robbie the robot.
That was a B9 in Lost in Space, and then you had Robbie the robot that, he took the crewman's whiskey or whatever and took it all, remember? Pour it in. He made him pour it into the robot.
I don't remember that.
Yeah, that was from, what was the name of the movie?
Forbidden Planet?
Yes, thank you, duh. Forbidden Planet.
Yeah.
Okay, 38. That's 39. That's good enough for this.
What
We'll-
next? I need to leave in a half an hour.
Okay, no problem. Because I'm just going to do the Purchase Cloud. And then we'll be done. All these dark locations in space, those are, again, the locations from which life springs.
Yeah. Who was the actor that just died? He was in Forbidden Planet. God, I can't think of his name. He was with, what's her name? Angie Dickinson in that policewoman or whatever that show was called.
Oh.
Earl Holliman.
Oh, okay, yeah.
Yeah, he was in Forbidden Planet.
He was the guy that had to pour his whiskey into Robbie the Robot to get rid of it, remember?
I think you're right now that I think about it.
Oh, come on! Yeah, pour it in there. That's right. Okay, now let's zoom out here. And let's now go down to the Purchase Cloud to see yet another area that's very different still from what we have seen. There's a nice star cluster, well, or a bright star actually, that's here as well. And there it is. This is kind of cool. Again, you're going to notice that stars seem to be missing. That's because we're missing, there's a dark cloud here. And I'm going to bring us down right here. If you guys are liking what we're doing, again, please consider donating to our cause at SkyTourLive.org. If you go to SkyTourLive.org, there's a donate button. You could donate, or you can join our Patreon. We have some benefits for people that join our Patreon. If you'd like to, that's a monthly fee. We have $3, $5, and so forth, up to $200. Believe it or not, we have people at every level, almost every level. But, it helps us out. Every little bit helps. Because we're going to, as we want to bring you better and better stuff, it's going to cost more and more. I don't make any money on this. I'm not taking any money for what I do here. Okay, we're going to do a 35-second image here. Yeah, so if you see your way, if you want to, you can, SkyTourLive.org. Donate. Doesn't need to be much, or join the Patreon. We'd love to have you. Then you'll get some nice exclusive stuff from us. Okay, let's make sure that, alright, good, we got that set right. And now let's go into our live stack and get rid of our embryo nebula image. Yeah, that's beautiful. And that'll be up on the server in moments from now. Actually, it's probably already there, sorry. Now let's see the Purchase Cloud. A very different region. Yeah.
Michael H. has a question of you when you have a moment.
Okay, Mark, only one question tonight. Only one? How big of a screen could I use to without stretching STLS pixels? Oh, good comment. Well, we're broadcasting it at HD. So you go to the HD resolution, and I was looking at my stream today. I was at Bill Skywatcher's house. He's our producer for our radio show. He lives in Newburgh, New York. I'm an hour and a half from there. And he actually put our SkyTour up on his 80-inch screen. And it filled the screen and looked beautiful. So it was pretty cool.
Is he asking basically how much could he blow up the image before pixelation becomes an issue?
That might be what he's asking, and maybe I just answered the wrong question for him. But I'll talk to you. I'll say it this way: if you actually, it's a 1080p broadcast, so you could actually put this on a large TV screen at 1080p and you won't see pixelation. All right, so and the reason is because the screen can support 1080p globally on its surface. If you try to zoom in on that, well, then you'll get some pixelation, but you don't want to. But if you blow it up really big, and you see our screen right here, it's this whole size here that goes all the way across, all the way to there. If you just blow up this one section and you zoom way in, okay, like this, well, yes, you're going to get pixelation. Okay.
Aren't you still on the last image?
No, this is the per cloud.
Oh. Okay.
Yeah, actually, it goes down further to the right.
Will you excuse me a moment, please?
Yeah, you go ahead. I'm going to actually start this over, but I'm going to move to the right
back.
a little bit here. Okay, I'm going to do this again. I'm going to move us to the right. I'm going to move this star over. So that means we're going to move to the west a little bit. Okay. Hope you guys are enjoying yourself tonight. I'm having a good time with you. It's a rather one-way conversation, though, I know. Okay, so this will be good right here, and now we'll do this again. 35 seconds. Hey, Stuffy, how you doing? Nice to see you. So I just moved this over here and up, so we're going to see more of the cloud that's over here. Okay, I didn't save it, so not yet anyway. There's our Perseus cloud there. Waiting for it to come in. Yeah, okay, let's do this. That'll be a little better. Okay, and then I will set the target name. Okay, here we go. Excelente. Alright, so get down a little more. I can still go over more because I guess I should. Darn it all. Okay, I'm going to go over a little more. Sorry, guys. You'll have to fire me. Okay, so let's go more to the west here. In fact, I'm going to take that star right out of the view. I'm going to go here. You'll notice the absence of stars in this very starry area, and that's because there's a big dark cloud here, as you just saw, kind of blocking it. And so we're going to just come up here now. Take this out of the view. Right there. Now the Perseus cloud starts here, but there's a dark cloud here that we're really focusing on tonight. Okay, 35 seconds again, and I'm glad I stopped because what I'm going to do is I'm going to increase our sensitivity to 350 here. All right, so we'll minimize this. And so when we go back to our live stack, we'll see the last image. The last image was this one. And now we've moved over and up a little, so this is going to be more this way. So we'll see more of the detail down here. Yeah, there we go.
That dark cloud on the right shows up nicely, though.
Yeah, it does. And I moved it into the middle a little bit more just now. So people can see that. This next exposure, you'll see what I mean. I moved the star out. Okay, so the star's up there. There's the Perseus cloud namesake, but then here is the entire cloud. It's not the entire cloud. It's a good deal of it, though. All right, we'll color correct that. This is the one we're gonna let go for a while. Look at how that's already showing up. Kind of reminds me of the Boogeyman, doesn't it?
You say so. Not as distinct.
No, not yet. It was only one exposure. There's two. We can already see some lightning on the cloud here, so it's lightening up. Okay. My black level should go up to just before the peak. And if we color correct, early on in the imagery, color correction will start to make it look a little better. But it's really bright up there, look at that. And this goes down to here. But we're focusing on this guy right now. We're not focusing on this. But it'll be there.
And the bright thing on the left is an artifact.
This is, yeah. That's an artifact. Yep. Look at this, Daryl. Looks like a loop and then another concentric ring inside of it.
Oh, yeah. I see that.
It almost looks artificial. Looks like two circles, but that's actually the natural layout.
Yeah, well, I mention those whenever I see them. I mean, are they real or are they just happenstance, placement of stars, or are they really following those lines? We've remarked sometimes when we'll see distinct clouds or areas of nebulosity that the stars seem to follow edges in the clouds or in the nebulas.
Yeah.
In the shapes we see.
Yeah, you're right. Sometimes we'll see, like along the edge of a nebula, we'll see stars and strings. And it's like, did the nebula cause those stars to form at some point? Or is the nebula shaped because the stars have to be placed that way? Really interesting. And this is a good blend of location here. So you color correct every now and then. Allows you to see the colors better. Here's that nice dark dense dust. Again, deep inside here the temperature is going to be minus 250, 260 Celsius, below zero. And minus 273 is absolute zero Celsius. Absolute zero is minus 273 Celsius. So pretty cool. And I mean cool as in very cold. You'll also notice some red mixed in. That's because hydrogen is the most abundant element in the entire universe. So you're going to have hydrogen mixed in with dust everywhere you look. So that's why you can get stars forming in dark nebulae like these, like with the Northern Trifid, because the stars are contracting and the hydrogen is contracting gravitationally. And if enough of it reaches a critical mass in the center with a critical pressure in the center, then it can reach a critical temperature in the center to start hydrogen fusion. And hydrogen fusion seems to be the power source of the universe, the initial power source of the universe. Interesting, though.
I see some dark tendrils showing up.
I know.
There in the upper right.
Up here?
Yes.
I see those. I see this here now and this here.
There's several of them.
Yeah. The colors are beautiful in here. Kind of reminds me of the Rho-Fuchsi Nebula. The Antares Nebula, Rho-Fuchsi. Up here, look at these tendrils up here. These are really nice. See the little tentacles, guys? Like little hair. These are thin, wispy, dark nebula. And it extends all the way across here. Really neat. Wow. Good night, Judy. Thank you for coming.
Can you zoom in on the upper right part?
Yeah, I will. Just a sec. That's a good idea. I just noticed that. All right. Well, Ross, I'm glad that you and Crystal are having a good time. You know. There we go. Look at that. That's nice. You can see some subtle tonality changes here, where other starlight is causing it to be brighter at the edges and then darker in the middle where it's denser.
There's one narrow tendril on the right of that, running from the top there. Actually, it looks like it's wandering down about 3/4 of the way across the page, down the page.
This?
Follow that down to that yellow star, or the red star.
This one?
Yes, and then go down below from there still. There's one part that's very skinny, just
Right
below
here?
where your pointer is, to the right of where your pointer is. And then all the way down to that dark area at the bottom with the star next to it.
Oh, yeah, we got another one like here. That's crazy how amazing this stuff looks. Yeah, that's really pretty. And then up here, you can see the detail in this, where it has its own dark nebula in here. That's pretty. When I've looked at the Perseus cloud before, it's a molecular cloud. That's why they call it a Perseus cloud. Clouds tend to be molecular clouds. And what molecules are we talking about? Well, we're talking about carbon molecules, carbon, where three of the four electrons are bonded with them in a way that allows them to be broken apart if needed, but they can actually be pretty strong. And then you have silicon, like Daryl was saying before, silicon molecules, and you have other materials in here as well, and lots of ice that is forming on the surface in these extremely minus 250 Celsius regions of space, waiting to be heated by a star that forms to form a stellar nebula that may form planets.
And that's the kind of stuff we came from, and maybe more beings like us are coming from right now.
Yeah. And see, I wrote a book called The Populated Universe, and it's really a study of how life could have happened and formed on the Earth, but how life could be happening in the universe. And the undertext of the subtext of the book is life in the universe may be the exception. I'm sorry, may be the rule, not the exception. And I put forth a case that a lot of people have looked at and said it seems to make sense that it's the carbon base that we're made of. Carbon is the most flexible atom in the entire periodic table, and it stands to reason, as I've said, that carbon is the molecule of choice for the atom of the choice rather for the universe to support life off of, because it makes and breaks bonds very easily, bonds with more things in the periodic table than any other element at all, way thousands and probably 1,000,000 times more efficient than the silicon atom right below it. And it's those things in the column rather, that are most like each other. So that's the thing about carbon. So silicon's not very good at that. It makes crystals, for the most part.
In that dark area, there are some very fine tendrils in there amongst it.
Right here.
One there's more right there, and up above your pointer.
Yeah, right here. I mean, it's actually. Let me see if I can draw those out here. Well, you can see it. This is sort of like a puffy cloud region. This is the first time I've imaged the purchase cloud with this new camera, so we're getting such a very different view of it than we have in the past. Look at how deep red the hydrogen emission is in this part of the nebula. And then up here, we're getting a gorgeous, beautiful view of this area here with its own dark nebula and dust. This is all dust. Look at these fine tendrils. These fine lines of dust. See them?
Oh yeah.
Look at that. These are just beautiful. So, wow. It's a very pretty, it's almost like a painting. Let's drop this down a little bit. It'll mute this a little bit. This is going to go. This is noise we'll get rid of. Wow. Yeah, this is going to be something else. I'll be coming back to this because we're going to want to image this separately and do this whole square up here, and
Might be worth mosaicing.
yep.
Another image above it.
Mm-hmm. Not tonight though.
No. I have to go.
Yeah, okay. All right, so we'll just do this 20-second shot. All right. I mean, we can continue without you, but it's about that time. We've been dragging people along here for the entire evening doing this stuff, so we're cool. Carbon Star says hydrogen is mostly in star-forming regions, right? Like some galaxies have little star formation. That's true. There are some galaxies that have sort of ceased star formation. And you say older elliptical galaxies in particular. Yeah, that's true because they don't have a lot of gas and dust in them. And because they were smaller, they probably... Well, actually, some of them aren't small. Messier 87, for instance, isn't small. It's a very massive elliptical galaxy. But yeah. Gas and dust are what make the universe go around. If you don't have a lot, you're not going to go around for long. Okay. All right, let's zoom out to show you the full frame. Look at this. This is so complex. Let's see what else is here. Let's over process right now. Boom. Let's see what we get. Well, there you go. Now you see over processing. And we could over process at times.
I wonder if the hydrogen emission up at top right is being caused by that bright star there.
This one?
Yes.
Seems like a red star. It probably wouldn't. It would have to be a blue star.
True.
Could come from one of these blue stars over here.
Okay. Since the dark cloud is in front, yes. So maybe the star cluster is what's causing the red to
Yeah.
emit.
Yeah.
Oh, cool beans.
All right, man. Well, if you need to go, Daryl, go ahead. I'll close up and finish out. By redoing the colors, there's a lot more hydrogen emission in here.
I see that.
Yeah.
Okay then. Well, I'm going to wish you all a good night and
All right, Daryl.
have fun. Take care. Thanks for having me on, Mark.
Okay, I'll finish this out. So, good night, Daryl. We'll talk to you tomorrow.
Good night.
All right, bye-bye. Okay. Well, it's just me now, guys. That's all right. This is really pretty. And lots of neat colors. When we get to the Christmas tree nebula in the winter, you'll see how beautiful the colors are. Yeah, it's really cool. Good night, Daryl. Thank you for joining us tonight. All right, let's drop the noise a little bit, and let's go see what our sky looks like right now. Yeah, there's the Pleiades, there's the Hyades, there's Jupiter, and there's Orion. We're not able to see Orion yet. It has to come up more. So we'll have to let it come up more. Boy, this is really pretty. Neat little feature right there that I didn't see. Just gorgeous. Okay, what does this want to be at? Let's see where it wants to be. Yeah. That only works if this is down here. Wow. Hey, Ronald, how you doing? Ronald's late to the game. Daryl was here for a couple hours and he already left. Okay, we're going to, let's see, we have 38. We'll save it now at 38. Well, there you go, folks. This is beautiful. You're literally looking at the place where life comes from. These regions here, these dusty regions, these are beautiful. The location that really is most important are these up here. These really dense clouds up here, the darkest up here, right? This red glow you see, this beautiful red glow, this is all hydrogen gas that's glowing. And then you have this beautiful dark dust, which is coursing throughout the universe here. It's also here. You're looking at the same dark dust as over there, right here, but the starlight is hitting the dust and causing and then the dust is actually scattering the blue light. And so you're getting this beautiful, what's called a reflection nebula that looks blue up here. So that's really pretty. But that's what we're seeing here, and it is literally the place where life begins, is in those regions of space in the dark. Life began in the dark. I'll play that song for you at one point. Yeah, there's more areas like this to see as well. But tonight we're at 31. I will take that and save it again. And save it exactly as seen. Alright. Well, guys, thank you for joining us tonight. I hope you had a good time. All these images will be up at skytourlive.org right above my head. And you'll be able to see see everything we've got and see everything we've done. And take these pictures and enjoy them for yourself. Alright? So you guys have a good night. I'm going to go to bed because it's been tiring. Alright? So I'll see you guys the next time we stream, which will be probably in a day or two. Let's see. What's tomorrow? Okay. Tomorrow at 8 p.m. I'll be on the Ken DaCosta show, I think. Tuesday I'll be on Martin Willis's podcast UFO Tuesday night. I'll be with Don Ecker, who famous guy, Don Ecker, on the 9th of December. And then on December 10th, I'll be on Coast to Coast AM with George Norrie. We'll be talking about astronomy and other things. So if you get a chance, tune in, check it out, hang out. I want to thank, one more time, I want to thank Woody, Petita's husband, for working on my car. Totally unexpected. Didn't need to do it, but he chose to do it, and I couldn't stop him once he started. It's like, get out of my way, let me fix your car. I was like, okay. Great guy. And I want to thank Petita and Woody for that too. Anyway, I also want to say to Bill Skywatcher, who is was going to join us tonight, but he had other things he had to do. I want to say thank you for the hospitality and letting us stay there for a couple days and visit. So it was a good time. Also, last but not least, do give it a good attempt. Go check out SkyTourLive.org, and if you can donate to us, fantastic. We got a lot of expenses with our new telescope system, and I got to tell you right now, I'm not spending money needlessly just to have like cool toys. It's not at all what I do. Okay, I'm literally creating a whole new way to teach people astronomy and the universe. And frankly, there's no one doing this. There's people that are out there streaming the universe and streaming stuff and taking a picture and streaming that they're taking a picture. But you're also getting a science lesson. You're getting input from real astronomers, not people that just like astronomy. And so you're actually getting some real science with some real factoids you can look up. And I put it to you, you can fact check me if you think I'm wrong. And I've been doing this for decades now. And so you guys can you take what I say to the bank typically and enjoy it and move forward with it. And again, I'm also available. You can, if you go to SkyTourLive.org, okay, right there, you can actually email, and the email doesn't go to some vapor thing. It goes to me, Mark, goes to me, right? I'm the one that reads the email, and so I know what's going on. And if you have questions about things, if you have questions about telescopes, I saw a UFO, what the heck's that thing in the sky? I got a video to show you. Or, you know, tell me about these dark nebula, and where can I do like real science experiments with dark nebulae and with star clusters? What can we do? Do you have any things we can do as a group? You know, and the answer is yes to all those questions. I can show you all these things. All right. So I hope you enjoyed it. I really did. I always do. As you can tell by the fact that I haven't hung up yet. But I hope you guys have a good night, and we'll see you again. All right. So take care, and when you go outside, keep looking up. Remember that even though the starlight is being kept from you by the light pollution, remember, we're going to take that light pollution and we're going to kick it away, because we take you to places on Earth like this where the sky is gorgeous. There's the Milky Way. There's the winter Milky Way right now. So yeah, so we take you these places, and you can join us, and we bring you the universe live in real time. So have a good night, and good night, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.